Okay, so what we left off looking at a couple of things, got a chance to play with a couple of editing tools and seeing, some of the capabilities, and particularly we were talking about points and what they are. So what I'd like to do is direct you to, I almost said point you to, but I'm going to direct you to a couple of things to think about here. If you're not very familiar with a Carlson point, starting on page 11 in the manual, this is sort of a explanation of what we mean by these Carlson points. And I'm not going to read this thing to you, but I'll point out to where these things are. Is that all of this work that we're going to be doing with Carlson is going to be performed on things in our CAD drawing, but the CAD drawing only has awareness of CAD entities, which include points, lines, polylines, circles, arcs, text, things like that. They're just basic drawing entities. It doesn't know, excuse me, that it should be anything other than just a piece of geometry. It doesn't know that you're working on a map, or if you're working on a dress pattern or a circuit board or a floor plan for a house. None of that matters. They're just drawings. So Carlson takes those entities and attaches some awareness to them or intelligence to them, and says, like we saw yesterday, as we turned a polyline that we drew into a center line. So then once that center line is defined, it saves itself. You'll save it off externally, and it's sitting out there in a separate file. In fact, you can go and open that centerline file even in a brand new drawing. It doesn't have to be in the original drawing where that thing was made. So as long as that's been defined, you can then always reference it and use it and draw it, station it, over in any other kind of drawing. None of that matters. So once that's done, that's the Carlson taking care of that part of it. It's taking care of these, holding this data here that you see in these external files. And that's what we use to annotate the drawings and, do whatever we need with the do our computations and such. So part of that are going to be these things called points. And so here's an example in your book here, and it, excuse me, sorry, I'm gonna probably lose my voice today. I apologize in advance. So there's a maybe a polyline, maybe this A, B, C, D might represent, a fence, or maybe a water line alignment or something like that. So you can look at that and say, just in general terms, yeah, there's, when we ask the question, are there points there? Well, yeah, I mean, they have bend points. They've got end points and bend points in the middle, or vertices. Each one's called a vertex. And, just in general terms, we say that has a point location. But in CAD terms, in terms of the drawing, there is not there's no CAD point entity at those locations. That particular polyline just simply has those vertices associated with it. Okay, so and they're still usable and accessible, but they don't have separate individual points to them. you can use the CAD system to draw a point at each of those segment endpoints, and it would just overlay that line that you see, and you could have those individual points on top of it. Okay. And so, but in terms of what you're looking at there, there's only this one entity, is this polyline. Okay. So to have points, right here, it talks about you'd have to issue the point command, and when prompted, you'd snap to the endpoints of each segment of the polyline, and it would put a point entity at those locations. That's what we were talking about, that point display mode and point display size. We were looking at our settings yesterday. Okay, but we like to think of these things as points when we're talking about, being a surveyor and we're out on the ground and we go out there and we measure those points. So here's an example of, even if we do put those points in the drawing, you can see there is a standard little CAD point entity, but over here is a typical Carlson point. Notice it has a point number, an elevation, a symbol, and a description. Okay. So what this is, and there's also, by the way, one of these CAD points right there at the at the origin of that symbol. So in this case, this CAD point is simply a single dot. It can be not, a dot's just one way to display it. It can also be, if you look down here at this example, you can also show it as an X or a plus or a circle and a stick. There's all kinds of different ways you can display those CAD points. But when we're using Carlson points, we typically associate a drawn symbol that we want to use for the mapping. But that gets added to the CAD point. And sometimes you can see them if our symbol is open, like this triangle, then you would still, be able to, if we're using just that single dot, you would see that little dot right in the center of that symbol. And that's usually the way we do these. But doesn't, have to be, it depends on how we display the CAD symbol, rather the CAD point as we display that. But now here's what to remember about these points is a Carlson point is made up of a CAD point, just like you see here on the left at the top, but it adds to it two other blocks. And blocks are nothing more than just little groupings of drawing elements, okay? And we group them into a definition and call that a block. So it has a CAD point entity, and then right over top of that, it puts a symbol, which is a graphic block, and it can be anything. It can be this sort of target-looking thing. It can be a triangle. It can be any of those symbols that we saw yesterday. And then it puts a second block right at the same location of that, and that's called this attribute blocks, this block of attributes. And it is composed of those three pieces of text that you see there, the point number, the elevation, and the description. Okay, so it's really sort of a complex thing called that's the Carlson point. Now they can be in our drawing, but we also have them associated with being in a coordinate file. So we're going to use those points then to help us do things like draw lines, like we saw in our description yesterday as we were drawing, point number to point number, et cetera, et cetera. But we're also going to use those, and this is the really the backbone of what we're going to do with our modeling, is that points are, and Bert, this is the same way you approach it from your what is it, PC survey. You're used to, all these points are going to be making up the surface. And the same is true in Carlson. Surfaces are made up of these points. Now, it gets a little more complex, and we'll talk about it in a little bit. But when Carlson makes a surface or a TIN, a triangulated irregular network, it models the ground surface by creating all of these little triangles that lie on the ground or on whatever surface, and they join other triangles at their edges, and they're sort of stitched together all across the entire thing that we're modeling, and all the edges are all common, and they're stitched together to their neighbors. Now, why do we use triangles, you might wonder, and the answer to that is that a triangle is the minimum number of points required to represent a plane. So those 3 points in that particular local instance define the surface by those 3 points. And then it moves a little bit, off of that triangle, and it has to define another triangle that is the best representation of that little patch of ground. So it's going to use another 3 points. Maybe it's sharing 2 of its neighbor points from the previous triangle. So bottom line is, we're going to be using points to create those triangles and those pieces of those surfaces as we stitch all those things together. Now, the concept to recall here, though, to remember with this, is that even though we say we're using points, they don't have to be physical Carlson point objects or even CAD points. They can be, and they can be either. But they can also simply be point locations, just like this little polyline here. There are no real points on those corners, but it reads that polyline as long as it has elevation, and it goes to each little vertex along that polyline. Or if these were 3 individual lines, it would use the endpoints of each of those lines and would use that location as a point as part of that surface. So in this particular case, when the computer is building this surface, it might sit on point A, and it looks all around itself in 360 degrees, and it finds the nearest point objects that it can find without crossing another line that's already been made. We'll talk about in a minute. And so it uses that as a point. So there's a point sitting at A, it sees this other point up here at B, it sees this point up here at C, and then maybe there's another line down here and it's got another point in it, so it starts to build all of these triangles and putting those things together. So they can be Carlson points, they can be CAD points, they can be the vertices of line work. They can be essentially anything that has elevation is going to be occupied and analyzed to become part of a little triangular patch of ground based on its proximity to its neighbors. Okay, we'll see all that when we get to that in a minute. So now, as we talked about, let's get back to points here a little bit. We talked about these points and how we use those to create our lines and such. I'm going to leave this other exercise to you for you to do on your own, in the next coming days or something. And that's talking about using these point groups. And all this is, I'll explain it to you, but we're not going to take the time to go through the steps. I want to make sure we can cover everything else on the surface building. But all point groups are is when once you have your list of points and they're part of your CRD file, like you see here, called pointgroups.crd, and there's our descriptions. Okay, so these point groups are, you're declaring a list of points with certain descriptions. They don't always have the same description, but you're creating these groups of points and you're naming those points. So you might have, in this particular case, and let's see, do I have a picture of that? Yeah. So in the exercise, and it'll step you through all this and tell you how to do all of this. But here's a particular map, and there's all these points that we're going to be putting on these, say, the property corners. And so we might have points here, called P core for all of these points that are property corners. But you've also got points that are the corners of these buildings and corners of the driveway and the the center line of the roadway and all that kind of things. And we make different named groups of similar type of points. And then we can refer to those as a group by name instead of having to, use the range of point numbers and such. So when we do like draw locate points that you're gonna, see here in this group here, you would you would choose the option down here at the bottom here to draw the point group. And then you could draw, in this case, in this example that the exercise is, we got all these points. They're not drawn in the drawing yet. We've made groups and we said, okay, draw a point group. And we drew the property corners group and we told it to use this circle symbol. And so that's what it did, is it just went in and drew all of those circle symbols on all of those corner points. So there it's all in one shot. It finished up the entire, um, just as if we tried to draw a circle and snap to the endpoints of each of those lines. So it's a sort of a shortcut way of managing a bunch of points. That's what point groups are. So I'll let you go through that on your own, as you get a little more familiar with things. Uh, like I said, the instructions are pretty straightforward. All right. Now, beginning on page 18, and this is a little bit of background. Again, we won't read this stuff to you, but I would recommend that you go back and read through this. It's sort of, we take, starting on 18, 19, 20, 21, 22, 23, and then some problems, 24, so 18, so 6, 7 before we start then getting into exercises. So you've got like an entire college degree in 7 pages, all right? So this is really stark background, but it's pretty much all you need to know. And this will
Sounds
explain
good.
some of that. And we're talking about these as terrain models, and this gives you a little bit of the background. How do we do them? What are we using? Contours, what they are and what they represent. I think we're all familiar with contours, but how do we generate them? How do we create those? And here's the process we see over here in this uh, basics, and we're talking about this triangulation process. And we talked about that already, that these triangles, the basic geometric form, are a minimum of 3 points to form a plane in space. And then we combine those triangles, the representing those individual planes, edge to edge, and we come up with a continuous grouping to model that ground. Now, Here we're going to step immediately into the problem that a lot of times we don't really resolve like we should. If you take a look at this, and we're going to talk about this concept here called a break line. Okay. So when we start to evaluate these triangles, every triangle edge that gets formed, and when I say formed, it's doing all this in memory and then writes it out to this file. It doesn't actually draw it into the drawing, although it can, but there's no real need to put that in the drawing as long as we can refer to it with this external file. So when we make these triangles, we understand that every triangle edge represents a line of constant or linear change in elevation between the two endpoints. Okay. Now, it could be that the change is zero from one point to another. In other words, it's flat at that spot, or it goes up or down by a certain amount. But we assume, for our purposes, that along that edge of that triangle, it changes at a constant rate. So if it were to be, it dipped down real steeply to a middle point between them, and then less steeply over to the end of the rest of that triangle edge, that would not really be a triangle. You'd have to split that up into two different triangles. So what I'm talking about is, say in this drawing, if it went from 100 to 110, we assume right in the middle is 105. But if on the ground, instead of 105, that was, say, 101. So it went from 100 and very slowly up to 101, and then it shot up to 110. Well, that triangle would not be valid because that's not planar through there. It's clearly, there's a crease in there. It goes up very flat and then it goes up very steeply. So I would have to have an extra triangle line from that midpoint down to the next corner it can find to represent that ground. So all of these triangles then are the minimum or maybe optimized arrangement of triangles that we try to model the ground with, okay? And so we talk about here that if 2 points are not along that straight line change in grade, then they have to be separated by a break line or by sufficient numbers of additional points to indicate that point in between. That's what we're just talking about. Now, the way that we sometimes get into trouble and the way that some surveyors who might not understand this process in total is we try to resolve these issues by going out there and just getting, hundreds and hundreds of points in the ground, thinking the more points we get, the easier it will be to represent that. And that's sort of the concept behind, if you're familiar with, LiDAR and laser scanning and things like that, we basically are just getting, you're collecting, like in a laser scan, you're collecting over 1 million points every second. And so you get just a galaxy's worth of points. And so if you look at each one of those points and try to evaluate, where's the triangle that I'm going to be a part of, and you look at its neighboring point, well, it's right there next to it. So that's about all you really need. However, when you're putting this together, you're surveying it out on the ground, you don't need to get a blue million of points. All you need to do is identify the points where the elevation changes or the direction changes horizontally. And then we put all those things together. But we need to do one additional thing, and this is this break line idea. And here's why we need to do it, and it's an issue. Because if you look at this rule right here. It says every point that we're going to consider, and remember, it can be a Carlson point, or it can be a CAD point by itself, or it can be the vertex of an existing drawn three-dimensional line work. Okay. But let's assume it's just points for now. And every point, when we are building these models, is going to be a candidate for, let's see, one second. Oh, okay. All right, we'll be careful. Sorry about that. My wife just, oh my God, she works from home on Fridays, and then her dad just fell. She's got to drive over and help him. So hope that's all right. Anyway, so each one of these points is going to be a candidate to be part of a surface patch or one of these triangles. And it does this by sitting on each and every point that it can find. And it starts to look around itself 360 degrees, and it finds its next nearest neighbor that it can see. It's not always the closest, but it's usually it usually works out that there's a little bit more math involved than just that. It uses what's called Delaunay's criterion. But so what it's going to do is it's going to look around and find these other points, and if there's nothing in the way, when there's nothing in between that particular point and the other point, then we think of that as that point is able to see that other point. Okay, that's what this highlighted first line here says. Every point can see every other point around it, and it would possibly form the edge of a triangle there, okay, unless there's something in between that point and the other point that acts as a barrier. And that's the idea of a break line. And you know what break lines are on the ground really are just edges. They're just things to really, it breaks the triangulation. But here's how this is to be illustrated. If you look in this figure here, this figure 1, we've got 4 points, and the computer has been assigned the task of building triangles out of these points. Now, obviously, there would be other points all around it and more additional triangles, but these would be how they could form in this particular local example. If we have this point of 100, it can see a point of 110, so it draws that line up there in memory, okay? And then it also sees this one of 110, it draws that line up there in memory. It could possibly see this point over here, 100, but this line here has already been formed. It's already been created, so point 100 can now no longer see this point over here, 100. Okay, so what does this represent then with these two triangles? You've got, you know, they've got a common edge. They are at elevation 110 to 110. And then it's got the other points that are 10 feet lower. One, you know, off this way to the northwest, it drops down to that 100. Down to the southeast, it drops down to 100. So this looks like a little ridge line, a little piece of a ridge at elevation 110, and it drops off to the northwest down to 100, and it drops off to the southeast down to 100, okay? Contrast that with the exact same 4 points, 100, 110, 100, 110, but if the triangles get formed in this direction first, because the computer sits on each point and looks around itself and creates these. So let's say in this case, this point in the northwest looked down here and saw this southeast point and drew that line. And so now what do these two triangles represent? Well, they represent a common edge along the bottom of a little valley, a creek bank or something, a creek bed or something, of northwest to southeast. There's this line at elevation 100, but then off to the southwest, it climbs up to 110. Up to the northeast, it climbs again up to 110. So obviously a completely different type of landform than what the very same 4 points could form in this regard. This being a little ridge top, this being a little creek
Valley.
valley.
Yep.
Okay. Go ahead. Question.
No, I was just muttering the same thing you were saying, and I was just curious how it identifies which one to make first.
Yeah. So how do we know that? And the computer doesn't, in other words, and it can do things completely incorrectly. And what we have to do is we have to create those break lines for the computer. We have to draw them in as edges. And if we draw them in before we build the model, then um, it's the same as if the triangle has been formed. So if we have these 4 points, and if we draw this heavy line here in, and then say, now go out and build the surface. Well, once that line has been created and drawn in, this point in the northeast at 110 can no longer look across to the southwest and see the point at 110 because there's a barrier in the way, right? And that's what that break line has done. You see, it's been added manually to force the triangulation in the opposite direction. Okay, so a valley floor, a ridge line, tops and toes of slope, backs of curbs, the crown of a roadway. All of those things we have to create or tell the computer to create it when it's drawing the map for us as their base mapping. And here's really the only rule you need to remember. That break lines are really nothing more than edges out there on the ground. And the rule of thumb is this: if it's an edge on the ground, we need to make it an edge in the data before we build the surface. Okay. Now that can be a lot of preparation, or with a little bit of smarts, we can have the computer do that stuff, for us based on the description of points and things accordingly. So that's sort of some of the stuff we're going to start looking at as we build these models. So if you look at another prime example down here at figure 3, this is one of my very favorite ways to illustrate this concept. This is a curb structure on the edge of a roadway. And these represent points that we can observe along all these edges. Now, a lot of surveyors sometimes will see this, and to keep, say, from a triangle from forming from A up to E, up through the air like this, or from C up to G, cutting through this part of the concrete curb. A lot of times the surveyors will go out there, they'll make sure they get a point back here on the back, they get a point on the top, they get a point down here in the face and a point up here, and they'll just blast in as many points as they can, all grouped close together. And then they'll go, 20 feet down line and get another blast of points. They'll get the back, the front, or the back, the top, the face, and the edge of pavement. But really, the only thing we need to get is 2 points that define the edge of pavement, 2 points that define the flow line, 2 points that define the top of curb, and 2 points that define the back of curb. But then we need to connect the lines that go through those points. So that's going to keep, if this line's already drawn, then that will keep A from being able to see E, but A can see point number C and point B, and that's a valid triangle. E cannot see A, but it can see C, which would be valid, and it can see F. So E to C to F back to E, that would be a valid triangle. E to G to F and back to E would also be a valid triangle representing the top, but it could not create E to G to C to E because this line is in the way, it's in between. Okay, so that's the approach that some people take is they just spray in a whole bunch of points locally nearby and hope that the computer gathers those points up first and then goes to the next grouping. But there's no guarantee with that. The only guarantee you have is if you create those edges, those break lines. So here's those invalid triangles we were talking about. So E looking through the air, C to G looking through the curb. So what we need to do is to create those edges so that those triangles can only lie in those particular planes. Okay.
I can.
Yes.
Do you do you do that with the point descriptions as you collect those points?
That is correct. Usually we'll take those like if we were to survey that little patch of road, we might call those edges of pavement, we might call those EOP, and the gutter flow line, we might call, FL for flow, or FC for face of curb, and then the top line TC top of curb, and then BC back of curb. And so then we tell the computer, hey, I want you to gather up all of the points that say EOP and draw lines between them. We did a little bit of that yesterday, if you remember, with the little example we showed with the manhole and the manhole, and we had the edge of pavement where I had to change the PT descriptions to to EOP because I had a reserve
Right.
word. So that's part of our
Right.
field to finish, and that's one thing you can do. Now, you so you would you don't have to do it through field to finish. You can simply do it by looking at your points, and if you know the description, you could manually draw those lines in between there if you were familiar with what those lines were. Now the
Okay.
other,
Thanks.
yeah, absolutely, but now that's talking about creating that line work from those Carlson points. But keep in mind, line work can come from other places. It can come from, aerial mapping, from drone data compilation. As long as it's something that has three-dimensional elevation information, that's all we need. So if it's already coming to you from, say, somebody else has already created part of that map, but all they've given you really are just elevated lines, then you can still use that. And so the break line is already drawn in part of it. So let's say you've got um, a parking lot that's drawn in a map, and you've got labels that show the spot elevation of the corners of that parking lot. All you have to do is take that drawn edge of that parking, and let's say it might be drawn down at zero elevation, but you have a label that says what the elevation is. Well, then you just need to turn that into a 3D line with those elevations. And now that break line has already been created. It's there. You've just taken it from a different source. So they don't always come from just Carlson points. They can, but they can come from any number of different items, from different sets of data. So Bert, if you remember on that job we did with that long, switchback grade change, a lot of that data, and a lot of people will do it this way. They'll get that little they'll get the contour map in, and that's what we had, say, from that sort of more of a drone capture, were those contours, but they had no break lines in there. And so what we did when we conditioned that surface is I went back to POSDA. We got, for those of you outside of Pennsylvania, that's our Pennsylvania, it's up in Penn State. It's the data repository of all kinds of GIS and geologic and geographic data repository that we can all get a hold of. But we can go there, and they've got collections of all of these break lines that somebody else has put in from the photogrammetry, maybe sometimes from satellite data. So we just download that and use that to help steer our surface modeling. Okay, so that was a case of, we sort of used some available data. It wasn't the greatest accuracy, and that's why, if you remember, we talked about needing to actually tighten that up a little bit prior to any kind of construction work. So all of that stuff is part of that process. And we also want to consider, and that's where we start to get into this discussion here as well, is, some of these data sources, where can we get those data sources? Either Carlson points or these other places, but here's the other part, and I'll again let you read that, is that, we have to evaluate this. We have to look at this data and try to figure out, is it good enough for what it is we're trying to do? So when we're doing that initial layout and coming up with those initial volumes on that rail alignment, that's probably sufficient. If we're ready to construct it, it probably is not accurate enough, and we'd have to go back and supplement that with some more data. So here's a case of, how do we do that? How do we evaluate this stuff to see if it's good enough? And the biggest and easiest answer, and probably the biggest tool we have, are our eyes. We just look at this stuff. We're gonna turn this stuff up into this 3D view, like you see here, and we're gonna look and see, hey, does that look good? Does that make sense? Or does it look like over here on this right-hand image, where these road edges that you see here in a heavier black and orange, and the stream bed center line in blue, maybe they're drawn down here, at 0 elevation, whereas they should be drawn up here at elevation. So in this case on the right, we can't use those as break lines because they're down here, and these points up here, there's nothing blocking them from looking across. Like, I can't, if you look, try to zoom into this data here. If I'm looking at a point, you can see this road goes through this, and that's an obvious road cut where it's going through. The bank is high on the left and it's high on the right. Well, if I didn't have those lines from along the road in between, I could be possible that a point over here on the top of the bank on the right-hand side could look across and see a point over here on the top of the bank on the left-hand side and decide that's an edge of a triangle. Well, it's going right through open, empty space, no ground up there, but that would be an invalid triangle. So that's why I need the line work in there, and it has to be up at elevation. It can't just simply be in plan view to drop, to block that view across point to point. So, we're going to look at how do we fix this stuff so that we can use it. And here's an example, or I'll give you the process as to what we do. Let's say we have our data that looks like this over here on the right. We've got a bunch of this sort of random data on the ground surface, and that part's okay, but I also need these things to be break line. Well, I've got some tools in the Carlson software that I can take that And let's say now we're gonna see, this is what this data looks like here on the left in plan view, but I need to make sure that this stuff gets brought up to elevation. And the way that you do that is, let's say it's down here at 0, and we look at it in plan view, and we see, all right, does it intersect any of these other lines, this other data? Does it cross any of that stuff? And that other data has elevation, but in plan view, if it crosses it, I can say, all right, I want you to analyze that black line or this orange line as you're walking along the ground in this plan view. And if you crisscross, if you intersect any of those other lines, I want you to take the intersection and read the elevation from the other line you intersect and assign it to the line you're trying to raise up. So it's what we call draping. So basically it's like taking the two-dimensional zero elevation positions of those things. You're picking it up straight up in the air, and then you're laying it back down and letting it cross, wherever it lands on this other set of lines. And that's how we get the elevations for those edges. But you can see in this case, it may not intersect anywhere. And so that would really sort of be a tough approach to do in that regard. So thankfully, though, this data, when it was compiled, this is a photogrammetric job. The people on the photogrammetry machines, they went ahead and created those for us at elevation. And so those were, absolutely perfect to use. Okay. So we're going to be looking at some of those tools. We're going to learn to use that 3D viewer and see how that's going to help us verify what we use to build that surface. And again, remember, we're going to start to create all of these little triangles. And you can see, this is actually, that's from that same original data. You see this little orange roadway up here and the roadway up here, and that corner that's sort of cut out. Never, we're spun up in 3D, but if we were looking straight down on it, that would be this little upper northeast corner, north being up this direction. Okay. So right there's what you're looking like. And so that's where all the triangles form. There you can see the orange edges of that roadway here, the heavier black edges of that roadway here, and all these other little gray lines and points where all these triangles are formed. But look out here. There's all these other real long and skinny triangles as well. And the reason for that is the same reason that we talked about these need for break lines, is that when we're sitting on each and every point in this drawing, when we get out to these, or maybe we're on a point here in the interior and we're looking around ourselves, and let's see, here's a good example. Say at this point, we look around, we see this point, we see this point, this point, this point, this point. And so we see all of those individual points and we start creating triangle edges. And you see, once we get to this roadway here, this is a ditch, this is the edge of the road. So here's a case where, this point here can't look across and see this point. This edge is in between. Okay, so there's an edge that blocks it and it has to go somewhere else. When you get out to the ends of these lines, there's no edges out here anymore. There's no further edges, but it's looking around itself. It's seeing these triangles back here toward the interior and they're fine, but it also can look way down here and find points down here because there's nothing in between. There's no boundary that caps that off. Okay. So that's sort of a special condition, and that's what we call a boundary, a surface boundary, an inclusion boundary. And so we're going to also see some tools about how do we create those? Um, how do we keep these from happening? And sometimes we also ask ourselves, does it matter? Am I working out here in the edges? Do I care? Okay, maybe my work is way over here in the interior, and I can just let that go. But you know, that's again how that's one of these potential problems. We've got these concave areas that are going to have these long, skinny triangles that we don't want as part of our model. So we need to, use these boundaries or these inclusion polylines. You're going to see that term as well. And remember, what we're trying to do is to keep the points on, from one particular object, whether it's a Carlson point or end of a line or a vertex of a line. We're trying to keep it from seeing other points if that's what we want to do. If we're trying to keep that triangle from forming, that's what we want to do. Because there's a great tool in Carlson. It's on the draw menu. It's called shrink wrap entities, but it's also now an automatic part of building your surfaces if you want it. But you can also just simply draw it. But again, the key is we look at things, we model things, we give it a shot, we evaluate it, we look at it, we see if it's correct, yes or no. Okay. And then from there, right, here's our key note. We're going to use our eyes, use your brain, use the tools that we make sure we get the right uh, work done. We've added the right break lines, etc. Okay. And now we're going to look at a couple of options here on what those do when we open up this file next. Okay, so let's start with let me see here. I'm not sure. Take it may not have it in this data set. I was going to say there's something that's pretty easily illustrative of this point, but it might be in the survey data set. Let me see something real quick. Carlson projects. Okay. Everything's good, right? Okay. Back home, dad's fine. All right. Now, so when we look at these, let's say I've got a civils. Yeah, no, I don't have it in our particular data set. I'll show you the one I'm talking about. That we use this in our field to finish. You may actually have the thing available regardless in your delivered data set. So let's go ahead and load up Carlson. That's the first thing. So when we load that up, um, 20, so we're gonna make, let's see, let's choose open files instead of new files at this point. So if I open a file, I want to look here in my samples, and let me see if I can find which one it is before. Oh, bear with me here. Some projects. It's called F2F on the Fly is the one that I use from Civil. And that is, or I mean from Survey. But it is also, all right, so if you go to open a drawing and you look in Carlson projects as your location, and this will be something that maybe has, and that's hopefully been installed as part of your installation process, just as sample drawings. And look for something, there's these files called demo 1, demo 2, and demo 3. See if you have those, and let me see if the one, all right, so it's not demo 1. I wish there was a way, and there's not until you can't tell what's in the drawing until you open it at least once. So that's why I don't get those. Oh, come on now. All right, still back to Carlson projects. There's demo 1, demo 2. Nope. Nope.
All I seem to have is the items that you sent us.
You don't have anything in your folder that says Carlson projects, like just demos or examples or anything like that?
I'm not entirely sure if I know where to access that on my system.
Just navigate to drive C, and there should be a folder called Carlson projects. You would just, come over here on the left-hand side, open up drive C.
Yeah, so not the settings, but there's example 1, 2,
Yeah,
man topo, and plat 4.
it's man topo, I think. Let me see. Is that it? Yes. Very good. If you've got man topo, load it up. And we're going to illustrate this brake line issue here for sure. And now, does yours look like this once you open it up?
Almost exactly.
Okay.
This color scheme's a little bit different. I got some more cyan on that little pit or whatever that is.
We'll take care of fixing that. Now this business here again is like a little stockpile down
Sinkhole.
in the corner. All right, and so I'm not going to be particularly concerned about that. In fact, I'm going
Oh, I guess
to
it's a
draw a little
mountain.
window around this lower right hand stuff and get rid of that just to keep our distractions to a minimum. And I'm going to,
Just hit delete on it.
yeah, just delete it.
Okay.
Then I'm going to, oh boy, let me see. Yeah, it does have a description. Okay, um, so now I see I've got a bunch of points out here on the ground. And we're going to illustrate how these triangles are going to form. Now, these points right now are just part of this drawing file. They have also been created and stored in a coordinate file of the same name, although we would not necessarily have it. But what I think we do, though, it's part of our normal installation. So let's go to the points menu and choose set coordinate file. And let's use the existing and new tabs. So let's make sure that you get the existing tab. Make sure you're in this folder that says C:\\Carlson projects. And then in the list of current folder files, scroll down and find mantopo.crd and choose open. Okay. Now, if we look at that, we see we've got points that are in the 100 some to 200 and some range. Let's go to our points menu and do list points. And we'll just list them all and say, okay. And there we've got these points. And we go into get the hundreds and the 200s. So that looks possibly the same. And then we're going to see in the description column something very conspicuous. I've got a bunch of them that say 17, a bunch of them that say 18, and then a bunch of them that say ground/shot. Okay, and we're going to use that when we come back to this in a bit. So to fix this, so we know which ones these are, I'm going to redraw these points. Right now, they're just sort of, I see a point number, I see an elevation, I don't see my descriptions, but I want to fix that. So let's do these steps in this particular order. I'm going to, again, click and with my left mouse button, go around to my lower right and click again. So I select all of those points in my drawing, and I'm going to hit the delete key on my keyboard and take them out of the drawing. Now they're still in my points, my coordinate file. See, there they still are. I just took them out of the drawing because I'm going to recreate them in the drawing. And I'm going to do a couple of things first. The first thing is that I don't like that attribute layout. So I'm going to go to recreate these points. I'm going to go to the points menu and I'm going to draw locate points. And this time, instead of taking the way they had come in, I'm going to change a couple of things here, but not on this screen. I'm going to cancel that first. I'm going to go to the back to the points menu and I'm going to choose point defaults. There we go. So now I'm going to up here at the where this, you see my little preview of my point number, elevation, and description.
Yep.
That's my attribute layout ID right here in this pull down. I'm going to make that 2. And I'm going to use this cross as my point symbol. That's fine. I'm going to say, okay, I don't care the layer it's on, but I'll just leave that like so. Now that I've got that set, I'm going to go back to points and draw locate points. And now I want to make sure I've got my descriptions checked on because I want to see those. Elevations, blah, blah, blah. Here's this I'm gonna uncheck this layer by description. I don't need that. But I'm gonna use point numbers, descriptions, and elevations, so those are all checked on. I'll give it a layer name of whatever, and then I'm gonna say draw all. And I'm gonna let all the points draw. And there they are. Now notice I now have a point number and elevation, and there's those points. I've got some that say 17, some that say 18, and some that say ground shot. Okay, that's really what I wanted to see. So you can tell there's something like all the 17s and 18s are over here. Now, if you're sort of familiar with how this would go, this is going to be this little graded area of ground, and there's going to be essentially a ditch around the edges here. And you might look at, say, here is an elevation of 15. I'm going to change that color so you can see it a little better.
I think your text on the screen must be like really small compared to mine. Because mine it looks like a lot of noise.
All right, so let me do a couple of things here. You say yours looks like noise?
I mean, I can see everything, but it's very crowded and overlaid on top of each other because of the closeness of the points compared to the text size, I think.
Your settings menu and drawing setup.
Settings, drawing setup,
What's your horizontal scale?
100,
All right, change that to 20.
21.08.
Yes, if you want 20 and your symbols of 0.1 and your text plot size of 0.08.
Oh, let's say, okay.
Now go back and do points, draw locate points. Make sure right here in the bottom you say erase and redraw for this
Okay.
duplicates.
Yep.
And choose draw all.
Ah, so much nicer.
Yeah, there you go.
Thank you.
You bet. All right, now there's one last thing I'm going to do, and I'll show you about. I've got these lined up a little nicer. But you see, this is what I call ugly font. Now, this is from the days of yore when we used to have pen plotters and we didn't have inkjet type things or laser type things. So we simulated, circles by these little sort of squared off edges. And so our pen plotter would make those, and it could do those a lot faster than if it had to do, let's say this letter O, to make a smooth looking O, it would take, several, maybe 100 little line segments to look like a true O, whereas here you've got 4. So it was a fast font. It served its purpose, but that is the default font that the system uses to create a Carlson point unless you have predefined this particular text style. We did not, but we're going to fix that. And you can do that with, on the draw menu, come down to text, and then you're going to set style. And that's going to bring up this little dialog where we're going to choose a particular style. You can also just type the word style on the command line and hit enter. Either one's fine. But we're going to pull down this current style name. Right now it's sitting on, in my case, standard. But you want to look for a particular name style called PTXT, and that stands for point text. So here is a style that got created for us on the fly once the point was first drawn, called PTXT. And I look over here to the right-hand side and I see it is composed of this font called TXT, which is this looking preview here. It's that little squared off looking text. If I were to choose, say, Times New Roman, it would look like that. If I were to choose you know, webdings or let's say wingdings, or let me get something that's a little better. Let's see. Gothic, semi-bold. Those are all actually fairly decent. Let's see.
Pristina, Pristina. It's a very interesting, like, calligrapheric.
mhm. Look, actually, I'm looking for one that I can find it. It's called Gothic, I thought, but
Gothic SHX.
yeah, so it is a shape file. There's my, well, you have it because you're using the AutoCAD version. We have this, we have these IntelliCAD versions, and the fonts are slightly different. Um,
Or it's not Goth. Well, it's Gothic
yeah, it's got a,
PHICE. It's like
yeah,
GOTHICE dot SHX is what I show here.
yeah. So ours are all going to be starting with these IC. Maybe let's see, complex MGDT.
Hey, Ken,
Yes, sir.
I selected Courier New. It looks pretty nice.
Yeah. Anyway, the point is, all right, here's for an example. So if I use this impact, you see that's a little heavy. All right. So I would typically, I would usually, the one that I use when I build my own is this Calibri Light. Okay, so I was just actually going to try to find one that was garish looking to show you how you could really make it stupid. But anyway, we're not wasting more time than that. So anyway, it's nice and pleasant and it looks good. Totally unnecessarily. That's pure cosmetics. It's still just a point. Now, here's an example. I'll show you one more of one of the reasons I like my IntelliCAD version better than my AutoCAD version is to do that in AutoCAD, we had to run the style command. That's what you just looked at, the same as draw, text, set style, or we typed style, and that's fine. This is its own separate command. Now, here's another place to do it in IntelliCAD, and it's all on this, what we know of as layer control. Now, in AutoCAD, you do have the same, you've got a layer control tool, and you choose that and it looks like this, where you've got layers, you've got hold on a second here, you got layers, you got filters, you set the colors of the individual layers, you set the line types, and all of this stuff, and that works very much the same. But notice in here, and this is if you have the IntelliCAD version, the way I got that was I pulled it from my toolbar, but it's also the view layer control. Okay. And so that brings up this dialog box, okay, which in AutoCAD, it only controls the layers. Text style, you had to run another command. External references, you run another command. But look at this. This is not just layer control. Look at the title in the red stripe up here at the top. It says Explorer. And right now it says layers. Look at this left-hand column. If I click in the category, these are the layers in the drawing. If I click blocks, these are the blocks that are defined in the drawing. If I click line types, these are the line types in the drawing. If I click text styles, well, these are the text styles, and there's that PTXT, and over here's the different fonts. I've also got any saved views, any visual styles. I've got my external references. So everything can be done in this one single interface, which is a lot handier than having to keep track of, let's say, just to keep just to find, just to deal in AutoCAD, deal with layers. You got this command, layers.
I know this is stupid, but
Yeah.
I went ahead and changed mine to that Gothic, and then I tried to change it back to the Cambry Light, and it's not taking. Is there something that I somehow didn't do accurately?
You do the style command. Make
Yep.
sure you're choosing this PTXT.
Okay, let's try that real quick. PTXT. Ah, okay, that's what happened. I didn't.
Now go over and choose the font, because the style command, and a lot of people mistake the style command. They'll name a style the same as the font. They're not really the same. The style command is just whatever you want to call something. And then the
Beautiful.
font is the actual font that you're going to use to build that style with. Okay.
Yeah.
All right. So now we have some points. We have this thing done. We got a bunch of points. Now let's take a look at a couple of things. When we want to see what this might look like as a surface, first of all, we're going to look and see, well, we see that there is elevation, like 19.28, 19.25. And we, assume, and since we said draw our points located on the real Z axis, then we're going to know that we've got those are at proper elevation. I'm going to go to my view menu, 3D view, drawing viewer, or in your case, John, you look at the 3D view window. We select our data. We bring this up, and I'm not sure I understand that. Let's see. Huh. It is all at 0. Well. Isn't that interesting?
Pretty close.
Well, I know, but it's not, is the reason I wanted to keep them at elevation was because I wanted to be able to see it in the viewer. All right, so I'm going to go back and reset this. I'm going to go back to my points menu and choose point defaults. And I'm going to make sure that I say, and of course, that's not the right place to put it. Okay, so let's go back to the points menu and let's choose draw locate points. So I'm going to redraw them. So I'm going to make sure it says erase and redraw. And somewhere I'm going to put these on, right here. See that right there? Locate on the real Z axis. I want to make sure that's on. So now I'm going to just choose draw all again. So it's going to erase those and recreate them. And now when I look at that in my 3D viewer, 3D view, drawing viewer, there we go. So now I see them, even with this ignore 0 elevation switch on, and I could see that, yeah, they have now differing elevation. In fact, I'm going to pull this vertical scale down to make it a 3-time vertical exaggeration. And you can sort of see, what this is going to start to look like. All right. So that's really just And I'll put this exaggeration back to 1. So I'm really just looking at that to verify that I indeed have some elevations. All right. Now, to make a surface, again, remember we've got, in this case, just a bunch of points. So let's use those to build our surface with, and we'll take a first crack at it and see what's happening. So we build a surface. Where would you think you would look for a command to build your surface, by the way?
Probably under the surface tab.
Yeah, I would look for something. In this case, on my menus, I've got a surface menu. And the process is, we've been talking about, is to triangulate the data. So I want to try, there's a command there, very first one, that says triangulate and contour. So that means run the triangulation, and as part of that very same process, you can have it draw the contours all in one step. Now you can always, you see the third item down, contour from 10 file. So even if you don't have this first command, draw the contours, you can just save the file and then you come back and draw the contours anytime you want. But let's do it all at once here to start with. So let's choose triangulate and contour. And let's take a look at this box, and this is one you're going to get very familiar with once you start to use this to model things. And it's got a triangulate tab, contour tab, labels tab, and selection tab. That is going to be what controls what happens. So let's look first all the way to the right at the selection tab. And this is where you can filter out certain things that you may or may not want to choose. Or you can specify that you only want to use, say, Carlson points, but no CAD points, or no 2D polylines. Now, again, if a 2D polyline is sitting at 0 elevation, it's not going to be used anyway. But, you know, again, you can filter different things. You can also, let's say if we specified this and we used inserts, those are blocks or pieces of text. Here's some elevation text. You can even use another point file, a CRD file that has not been drawn in the drawing. It can go out externally, read the points, and create that into a surface in this drawing. Okay, that's just part of the capability that you have. But I'm going to make sure that I have all of these things unchecked because I do not want to filter anything. I want to be able to use everything that I select as part of my triangulation. Now this will stick between times of running the commands, even in different drawing files. But it's always a good idea to, at least the first time you run the command, to check it to make sure that you're doing what you want to do. Now, back to the triangulate tab. This is where we're going to control building the surface. And then we're going to go to the contour tab, and the contour and label tab work hand in hand. If the contour tab does not have the draw contours checked, then nothing is available on the rest of that dialog, which also, since no contours are available, no labels are available. Okay. Now, this is, and when we talk about this as best practices, this is the way I usually do my surface modeling. Is I build a surface and I write a triangulation file, and then I'll evaluate that file by various other means, like my surface viewer, or maybe I'll cut a profile across it, and I'll look at things before I ever draw the contours, because drawing contours is just drawing lines in the map. Okay, now that may be what we ultimately come up with as our finished product, but for my purposes, I want to make sure I'm comfortable with the surface before I draw the contours. And so I usually leave this unchecked. And then I go back to that other command on the surface menu that says contour from 10 file, because I've saved the file. It reads the file and draws the contours for me anytime I need. But for now, we're going to actually draw the contours. So we'll do that so we can see it immediately. Okay. So on the triangulate tab, I want you to check the very first one where you see write the triangulation file, then choose the select button. And let's give this a file name, and we're going to call, I don't care what we call it. They're in their Carlson projects folder. Let's see, let's call this man topo, since that's the name of our drawing file. Call it man topo -eg for existing ground. Okay. And we'll choose the save button. And now you see the file names listed. And then underneath that, you've got some draw options where you can draw all these different things. Now, I'm not going to do that yet because I don't need to. I don't need to draw the triangulation lines. I can see those triangulation lines in my surface viewer, and I don't have to hog up my drawing with all these extra lines. Okay, but sometimes you'll want to bring them in. Now, I'm going to uncheck this use inclusion and exclusion areas. And if you have this as a shrink wrap parameter reduction, pull that down and choose none. We'll talk about that a little bit later. Okay. Erase previous contour entities. Make sure that is either set to on or all contour entities, so that it will erase any contours that might be erroneous when we go to do it a second or third or fourth time. We want to make sure we say ignore zero elevations. So if we had some zero line work elevation, it could ignore it. Nothing else is checked in that little group. Our minimum edge length for interior and exterior, I mean maximum edge length, not minimum. I'll just keep those both set to 2000. I'm going to uncheck densify break lines and uncheck everything else. So it should really only have the write the file and the ignore zero should be the only ones on. And then let's go to the contour tab. And the very first thing is,
Hey,
yes,
hey Ken,
yes, sir.
I'm doing something wrong here. I'm in the triangulate deal,
Uh-huh.
and I have the right to triangulation file, and I hit select,
Okay.
and I get the other dialog window that comes up, and I put in man topo EG, and I
Okay.
hit save,
Yep.
but it doesn't show up on my window. Um,
It doesn't list it for you here. Does it say 10 file name and then it's just blank, or does it
no, okay, yeah, it's here now. Okay,
there? Okay, good.
thanks.
You bet. All right, so now we've got the fact that we're going to, whatever happened with whatever results, we're going to be saving this file. And let's go to the contour tab now, and let's turn on to draw the contours. And let's make sure our method is to draw a contour by interval. And we want our contour interval to be, over on the right, to be a 1. And we want to turn on to draw the index contours. And so that's going to be 5. Now notice if I change that, let's say from 5, it knows it needs to make the indexes say 25, but I'm going to use 1. Now there's one of them, like, they may have fixed it. There's one of these didn't automatically trigger it. You had to fix it yourself. There it is. If I make my indexes every 10, but I keep my contour intervals to 1, I get, you could do that, but it didn't automatically update it. So, but anyway, I want to be contour interval of 1, draw my index contours of 5. Now uh, your layer names that these are going to go on, I've got V-topo-int for intermediate and V-topo-idx for index. That doesn't matter for right now, but you'll see when it draws these, it's going to create those, either create the layers for you out of its default, but it will color them differently. So you'll see them. It's not going to be a problem. Just don't worry about the layer names. All right, so I'm going to make that contour over 1. Draw my index contours with an interval of 5. I'll make sure that none of these other check boxes are checked, including the no smoothing for our contour smoothing. I'm going to leave that turned off. And then on the labels tab, I'm going to turn on to label the contours. And again, I'll just take most of these defaults as you see them here, but I'm going to come down here to the check boxes toward the middle, and I'm going to check on to label the index contours only, hide the drawing under the labels, align text with contours, and draw on the real axis. That's the only ones I want on. And then for the internal label intervals, you can either do a certain number of labels per contour, or you can do a distance. And I'm going to do a distance. I'm just going to type, say, 200 here. And so every 200 feet, it will put a label down. Let's see what happens with that. Okay. So now that's all good to go. I'm going to choose that and hit the OK button. And it's going to put me immediately into a select.
What was the scalar on that? Unfortunately didn't see that last.
It was like an 8.3. I went a distance. I just typed 200, and I don't care what the scalar is.
Okay.
It's a weird thing that they changed, that they display that. It doesn't matter.
Okay.
But and I don't know exactly. I think what that is it computes and basically tells you how many inches apart the labels will be if you plotted this at the scale that you're plotting. I think that's what that number is, but I think of it in terms of ground distance. But anyway, so now it puts me in a select entities prompt. I'm going to make sure I'm reading the line above, because depending on what we have set in those check boxes, it could be asking us to pick an inclusion boundary, an exclusion boundary, and things like that. So right now it says select the points and the break lines that you want to triangulate. Right now all we have is points. So we're going to just either draw a window around everything, or we can just type the word ALL and hit enter. That tells us, okay, you selected 1031 entities. And select entities. It wants me to keep selecting if I need to. I'm done selecting. I hit enter. And off it's going to go, and you're going to see it's going to generate some contours. And oh, hey, look at that. And there are those in this industry that would say, congratulations, you just created a surface. Well, I'm going to be one that's going to tell you that that is correct. Your computer came back with the end result and did not report an error. But look at that. It's a mess. What does it look like? And I look at, just the fact that I know what contours look like. I know this is a mess around these edges. And I said, well, okay, maybe let's take a look at it in our 3D viewer, see if we can gain some insights into that. So if I look at that in my 3D viewer, I see basically the same problem. But I look over here and I sort of get the sense. Let me pull a little more vertical exaggeration. All right, so I can sort of sense that there's probably, you see how that looks like a ditch line? And maybe, wow, okay, so those are supposed to maybe be ditches, but you've got major problems with that. Okay. Now, I've also got another viewer called 3D View, my surface file viewer. That's on that same menu. And now there's this file, mantopo EG, that I want to view. And I can see this as a continuous
The whole
set
thing
of,
you just did, you went really quick. I'm sorry.
what about
Back to how do I get to this view right here?
on the view menu, 3D view,
View, 3D view. Okay.
and you should
Surface.
have surface file. You see that?
I got surface 3D viewer. It's probably it, right?
That's it.
Yeah.
Yep. And then
Yeah.
choose that file that you just created.
Okay.
All right. Now, this is the exact same viewer. It's just reading a surface file instead of the things we selected from the drawing. And you're either going to see something that looks like that, or looks like that, or maybe looks like that with colors, which when you see anybody from Carlson, any of the programmers or the sales guys, when they demo this stuff, they put it in the 3D viewer, they always use this variated color scheme. I don't particularly care for it much. I'll use it from time to time to make sure I've got my good data distribution. But to me, it gives a false sense, that this doesn't tell me anything. They'll do that, they for whatever reason they're in love with that. But anyway, I'm gonna leave it off and recommend you do as well. But now here's a couple of things we need to learn about the controls. Okay, is up on the right hand side, you've got these three different tabs. The view control is the first one that you're going to land in. And you have the choice to ignore zero elevations or not. So we're going to do that. Leave it on. Color by elevation. Again, I'm going to leave that to none. And that stays with whatever setting you've used last. And you can do this sky business with clouds. It's cutesy, gamey stuff, but it doesn't do anything, just takes up memory. Um, and then this vertical scale, that's the amount of vertical exaggeration. So if I want to have like a real,
Yeah, I went to like 15 or something, which actually really, really shows what's going on
yeah,
up in here.
so that, there's a problem with that, but sometimes you need to do, and again, that will also stay, um, from between sessions. All right, but now here's a couple of things. This camera-based light just basically changes um, the direction and stuff of the light that is based on the camera position, which is set over here in these settings tab. But it's this guy right here that's really going to control what we're seeing. And if we think of this blue, that blue is like, the sky, but, or actually the earth, and this yellow that you can grab with the mouse and move around. Think of that as the sunlight up in the sky, as the sun in the sky, and we're dragging it around. So if I want to see shadows cast, and this is sort of the way, um, this is sort of the way that we've been conditioned as human beings to think of shadows as being down and to the right. So our light source is always up and to the left. And that came about because of advertising, because that's the way most drop shadows were made. So that's going to be what makes us see this, say, ditch structure over here. So if you pull that, say, down and to the right so that it's going the other direction, now that what is a ditch looks like a little ridge line. All right, so that's just a means of helping you to position the best. And then you've got, brightness and contrast and all of that. You can also, over on the model tab, open up the surfaces item, select that surface, right click and choose surface properties, and you can change the color. I like this 93. You can set a level of opacity. You can even set a particular texture if you want. Okay, just whatever you'd like to see with with that, and or you can just live with the colors as they get randomly assigned. Now, the next set of controls are going to be what we use to help us visualize this or any kind of stuff in our drawing, actually. So we've got these 2 rows of buttons, and the one that we have that you're going to be able to toggle on and off is this one that looks like a little fishnet that's colored in, solid, and it's just a toggle. So if you press it, you're going to see that you'll see those triangles as solid edge-to-edge objects, or you're just going to see the outlines of the triangles. Even if you have them colored in, you can still, on the settings tab, choose to display triangle edges so that you can see where they are if you want. And you can even, if you're doing the surface viewer, you can display your contours. You see, those are the same ones that we generated, and you can change the contour interval, or say half foots. So you can see and it generates all this stuff right immediately in memory, shows it to you, and whether or not you want to use it. All right. But for now, so here's how we can take a look at this and how we can navigate our way around it. Now, here's the secret to the navigation. Make sure in this rotational axis, but you see how we can slide these around and, do this kind of business. Make sure when you're using this tool, make sure that middle one is locked. And I'll show you why and how, because it's going to really help us learn how to navigate. If we keep that one locked, that's its default condition. So I'm going to go back to these icons. I'm going to hit the rightmost on the bottom so it goes back to plan view and zoom extents. And let's talk about what these icons mean. The first one, which is a hand, that's my pan mode. Now, you don't have to use the icon. You can use any one of these other icons, but press and hold the wheel on the mouse because it pans just like it does when you're inside the CAD drawing. The wheel also, when you roll it in and out, zooms in and out just like in the CAD drawing. Okay. The other items, I'm going to skip the second one for right now. That's the one we're going to come back to and finish with. The magnifying glass one, those are your zoom modes. So you can use those to like zoom a window and zoom around. But again, if you just use the wheel on the mouse, that's going to be the zooming and panning that you can sort of get rid of 3 of those icons because of that. The bottom row, there's your toggle for your triangles. And this arrow is if you're in a surface file, now becomes this 10 edit mode where you can swap edges, add break lines, remove points, remove triangles, etc. if you choose to do that. I don't recommend doing that. That's not, to me, if you've got a problem with a 10 file, instead of trying to fix it here by making edits, go back and fix the data that caused the problem in the first place and recreate the file. That to me is a much better approach. But anyway, the control is there. Then you've got two little plan view buttons. You've got a reset to plan view, and then you've got a zoom extents. So if you put it back in plan view, let's say you get things all turned around, you know, you don't know, maybe you're upside down. If you just go back, click back to plan view and zoom extents, that puts you back looking straight down on it. Now, here is the way to navigate your way around any model. Is you want to use this second from the left on the top row, that icon. It looks like a cube with a circle around it, or the old versions of the software looked like an X and Y, and then it had a rotated Z um, to show on there. But that's the control we're going to use, okay? So we click that icon, and now just move the mouse from the edge over into the drawing area. And notice as I go left to right, as I get over the data, mostly, it switches to an X and Y depiction. And then when I get off the edges of the data, it switches to a Z depiction. Now, it's not exact, okay? It's, remember, you're looking in a perspective view, so there's all kinds of things. So same thing, up and down does the same thing as left and right does. But here's the secret to knowing how to navigate your way around. If you leave that middle button over here on the right checked as locked so that it's not going to roll on that axis, we're going to choose this icon and we'll come over here and get over the data and make sure it shows us X and Y instead of Z. And here's what we're going to be thinking about. You're going to imagine yourself standing in your driveway looking at your garage door. And what you're looking at the ground here, you're going to pretend that's your garage door. And you want to reach down here toward the bottom, make sure it stays X and Y. Don't let it turn to the Z yet. And get, relatively low as you can with it in X and Y. You're going to click and hold the left mouse button, and you're going to push your garage door up. See how I'm raising it up into my house? Now I'm going to go back, let the mouse button up, and I'm going to grab another chunk, and I want to lay it back at about an 80 to 85 degree layback angle. Okay. And then I'm going to let the mouse up, and now I'm going to put the mouse down to the bottom part of the screen where it becomes a Z cursor. And I'm going to click and hold the mouse, and I'm only going to go left and right because, nothing else happens. So I'm going to spin this thing around, and then I'm going to point to where it is I want to look, and then use the wheel to zoom in and out. So what you do is you lay the data back, line yourself up with the orientation, and you can, do little tweaks here and there, and then you can zoom in and out, pan back and forth, and you can see, take your time with some of these settings over here to help you visualize what you're looking at. So we can see basically we've got some, well, it looks like should be ditches, but they're not showing up because we got a bunch of weird looking triangles. Now, if we're looking at this, let's say if this is a ditch, can you sort of visualize? Here, let's do this. Maybe give it a, there we go. So you can sort of visualize that should be a ditch, right? But what's happened is that I've had triangles have formed what I can look at, say this edge right here that looks like maybe that should be the top of the ditch. And this down here should be the bottom. But because there was no line drawn, this point up here, this point right here, was able to look down here and see this point down here, and yet it looked right through the ground, and there should have been a line drawn across here. And the effect would have been like this. I'm going to show you with an edit, but we're not going to save this file. So this 10 edit, I'm going to pull this list down. I'm going to choose the arrow icon. Then I'm going to pull this down and I'm going to say add a break line. Now I'm going to choose right here. I know there should be a break line between this point and this point over here. So I'm going to double click this point. I think. There we go. So let's undo that. So I'm going to double click this point and then double click this point. And you can see how that healed that up. And let's do the same thing, say for the bottom of the ditch. I'm going to double click this point and say double click this point. See how it fixed that? And now I'm going to come here and double click this point and double click this point. All right, now that looks a lot more like what I should be. And I could go through here and, you know, fix all of this stuff up.
How do you get the surface and the grid again? For some
Uh,
reason, I can't quite
my
find it.
settings tab and I said display triangle edges. Okay, now you could have simply done, you
It
know,
doesn't seem to
yeah.
show it shows the triangles, but doesn't show the surface like that there.
Well, then go back to the view control and you toggle that on and off.
Where just on here. Ah, okay, thank you.
Okay. So you could do that, you know, if you recognize this and you could go through here and let's say, you know, we could keep adding, uh, break lines, you know, as we go around and sort of fix. Excuse me, sort of, you know, you see how it's already taken shape, but we'd have to sort of trace our way around and draw our way around all of that kind of stuff. And we would do the same thing, say over here on this edge, we would go, let's do it from here to here, from here to here, from here to here. And then let's see, from here to here. And so we could, you know, fix a lot of that stuff maybe by doing these kind of edits. And and a lot of people do that. I'm not a big proponent of that. Again, I like to fix the problem in the data that caused the problem in the first place. All right, so I need to figure out there on the ground what's making all of this stuff go goofy is the fact that I don't have these break lines drawn in. I can't wait till after the fact and draw them. If I had a means of drawing them in first, I would do that. Okay, so here's what we're going to do. I'm going to choose this exit icon at the bottom to go out the door. I'm not going to save the surface. All right. Now I know we've got a bunch of drawn contours in here that are incorrect, but I'm going to see if I can figure something out. Well, I see down here that I've got all these points called 17, and it goes to an 18, to an 18, and then there's a 17. And look at the elevations. I go from almost 10 to 8.3, 8.2, and then all the way up to 17.5. Well, that looks to me like the description 17 would be the top of my bank, and 18 would be the bottom of the channel. Let's verify that over on the other side, for instance. So I go from 17 to 18 to 18 to 17. So that's 17.5 down to 876 to 872, and then climb back out to 1296. Again, the same idea. Points with the 17 designation look like they should be the top of a bank, whereas the 18 designation should be the bottom of the ditch, climbing back to 17. So if I could figure out all those points that are 17s and connect the dots, and the same thing with the 18s and connect the dots, then I'd be a lot closer toward being able to model this correctly. So let's do that using a couple of tools. So the first thing I want to do is I'm going to get rid of all of these contour lines and labels. And by the way, while you still have the contour lines and labels out here, I'll show you a little trick. On the surface menu, let's go to the contour utilities, fourth one down or so, and go down to the right and choose move label along contour. All right, so it says select the contour label to move. So I'm just going to select, say, that piece of text there. And now, once I've selected it, I'm not holding any buttons down. I'm just sliding it along. I'm just moving the mouse, and you see it walks the contour. And let's put it, say, right here. And so you see how it looks like it's broken the contour. It hasn't really broken it. That is a piece of text sitting on top of what's called a wipeout. So if I turn my wipeout frames on, there's what it looks like. And it's just a particular little shape, and it is the color of that is defined as the background color, and it sits there. It's layered in the file by the piece of text is the frontmost layer. And I'm not talking about in elevation. I mean, it's the thing that's closest to you that's most recently drawn. And it sits on top of the wipeout. And then that sits over top of the contour line. And it also sits over top of anything else that's in the drawing. So if I were to say, copy this and put it, say, you see how it's blocking out this other stuff? Okay,
Yeah.
that's what a wipeout is. So, and then I'm going to turn my frame back off. But that's a neat little way to mimic breaking the contour lines and putting the labels down. And plus, it gives you a chance that if you've got a label in an inconvenient location, you can, uh, just select it, and you don't have to try to re-rotate it, to match um, the place where it's going to go. All right. Now, let's get these cleared out of the way and go to work on what this should actually look like. So let's go to first the edit menu, and let's choose erase, and let's go ahead and choose erase by layer. And let's select the layers from the screen. And I want to pick the text, one of the index contours, and one of the intermediate contours. And when I do that, it's going to identify the layers that those things are on, put them in my layer list. I'll make sure I've got all checked, and I'm going to say, okay. Now it's going to clear all that stuff out. I'm back to my points. Now, I've got a number of ways that I can do these points and do the lines. Okay, I could take a look at, say, this point 17, which is number 143. Here's number 142. Up here's 144. So I could sort of get a sense that they are sequential. And I could go 140. I could try to figure out where it starts and take it all the way around to this end up here where it ends. There's 17, there's 156, there's 157, 158. Well, over here's a 10, so that looks like it goes from 10. I don't see 11, but I see a 52, a 51, a 50. So it looks like 50 comes into 51 to 52 to 53 to 54. Looks like
55 is down to the right.
yeah, but 52 is 17, and then it switches at 53 to become 8.
Oh,
So here is 10 is 17, but I don't know, where's number 11? Now, here's a good tool for you to know. I don't know where point number, I do, I see it is right here, but if you were looking for something, you didn't know where something was, and you want to find that point number 11, it's an inquiry type thing, right? You're going to ask it a question. So we're going to choose the inquiry menu, and I'm going to choose find points. Now, when I run that command, I see, do you want to find by number or by description? Well, let's find by number. And it says pick the point number or a range of point numbers to find. Well, I'm just looking for number 11. So I'm going to say 11 and type enter. And it's going to jump me there and mark it for me. But you can also do a range of points and it will resize the screen to include all those points visible. All right, so now there's 11. So here's what I want to we're going to look at here for a minute. We could draw these points, these 3D lines. They need to be 3D lines. And by the way, that little glyph is just temporary. All right, so we're going to go to the draw menu and we're going to choose 3D polyline. Okay, and I'm going to come down here in the layer name. I'm going to call this, I'm going to highlight that. First of all, I'm going to uncheck this current drawing properties if it is checked so that I can type a layer name and call it top bank. Okay, and up here at the top now, I'm going to make sure that I've unchecked this prompt for elevation or slope. So it's going to, I'm just going to use point numbers and it's going to read the elevation of the point number and use it. Otherwise, if I say prompt, it's going to read it and it's going to ask me if that's okay. Well, I don't want to do that. And I also don't want any elevation adder. So I'm going to turn off that prompt. And I'm going to put this on a layer called top bank, and I'm going to set the color. We'll make it yellow. And I'm going to say, okay, now we're going to go from 10. Let's just go 10-15. All right, so there's 10 to 15. And I must have missed the color assignment. So 10 to 11 to 12. So that looked okay. Maybe this 10 is not exactly right. We don't know for sure. And here's the problem because we've got 53 to 54. All right, so I've got 51 to 52. There's 50. There's 50. So 50, 51, 52. All right, so let's try that one. So we'll do another 3DP, top bank, set color. So 50 to 52. And then 53 to 54. And this is bottom bank. I wonder why it's not reading that color. All right, so the bottom of the bank is going to be 18. So I've got 93, 94, 95. So 93 to 95.
Are you doing
And
that in a different color?
yeah, I'm going to. I'll have to fix the to fix it by layers. It's not giving me, it's not changing the color in the command like it should be. All right, so and then I've got let's see, 95. So if I um same thing. We're gonna go from 95 to 97. All right, so let's fix my layers now. I'm gonna go to my top bank because apparently it's not gonna let me set discrete colors. All right, so top bank will be yellow. Bottom bank
Yeah, points.
will be, let's make it,
Layers. How do you get to this screen again?
that was my layer manager. Layer, in your case, you would go to view layer control. I chose it from my icon on my toolbar.
I'm gonna call the bottom bank a different color. You said purple or something magenta.
Yeah, I'm just, so I've got my 17s are my tops, my 18s are my bottoms, and I can see already I've got a problem here because I've got these two lines that are crossing each other right here, and we can't have that because this has one elevation and this line has another elevation. And in fact, if I want to go back to my inquiry tools, I'll go to my inquiry menu and I'm going to choose drawing inspector on and off. And I'm going to right click the mouse and I'm going to turn off the layer name. I don't care about that. I'm going to right click the mouse again and I'm going to choose display elevation. Now I'm just going to hover the mouse. And so watch what happens as I go along this line. See how it's changing in elevation. So when I get near here, I've got like 5.123. And now if I get on the yellow line, I see that I've got like 9.58 and then 9.57. So they can't be 9.5 feet in the air along this edge, but 5.5 feet along this edge. So something is sort of out of whack right there. So we need to know how to fix that, and probably we'll just fix it by trimming off a couple of things. We sort of need to know where that goes, but I've got 157 to 158. See, these things come around again.
Same with
Now,
point 53 is the same way, right? Just
yeah,
below where that
yeah,
mark is. Yet
yeah. So 53 is an 18.
at 5 feet and
53
10.
to
Yeah.
54 would be, if I were to draw, I'm going to turn off my drawing inspector now. So I'm going to go back and I'm going to keep these back here on bottom of the bank. So 52 doesn't necessarily connect to 53, but it is the sequential point. I'm going to say 53 to 55, 55. All right, so that looks good, but again, it crosses this 10 to 11. So 10 to 11 probably doesn't apply. It's probably should be 10 to 158. Uh-oh. Let's see here. Let's undo that. All right, so 10 to 158. There we go. And I need to really remove this segment. Well, how do you remove a piece of a 3D polyline here? This is, if I select this, I've got that. I could do it by getting the grips, hover over the grip, right click, remove vertex. That might be the quickest way of doing it. Or remember those tools I said we could edit polyline utilities, remove polyline vertex. Well, there's also a remove polyline segment. Icon tells me it's on a toolbar. So I'm going to choose that and get rid of this segment here.
What was that tool? What did it look like?
Edit, polyline utilities, remove polyline, and remove polyline segment.
Yes.
Now look at the icon.
Yeah.
It shows a polyline and it shows the segment is red and there's a pencil eraser over getting ready to erase it. Same thing as the icon below that, the remove polyline vertex, only the vertex is red and the pencil eraser is above it. So looking for those icons on a toolbar, I see that they are on my polylines toolbar, which is up here at the top of my screen. You see that right there is remove polyline segment and there's remove polyline vertex. So very handy commands to know. All right, so now we're sort of getting the sense of where these things go. And it looks like maybe this guy goes from, instead of there, maybe it was supposed to go to there. And maybe that went to there. That went to there. And let's add it's hard to know, where this thing goes. So it looks like 17, 17, 17. So those connect all the way around to here. But maybe that 17 goes to that 17 and this, but we've got 18 here and 18 here. Maybe they peter out here. It's just hard to know. There are no 17s on the outside of these 18s on the back side. So that's probably okay. Not going to be too concerned about that. Maybe though, this, I think it does this. Here, let's see, pick. I think what this does 51, I think actually does go to 52. And then, so 50, 51, 52. Ten to 11. Here's what I think is actually happening is that 10 goes to 11. And then here's, see, 157 to 158. Oops. To 7. So I think it's probably looking like this. And don't worry about trying to duplicate what I'm doing. I'm just trying to get a sense of what it looks like here. And then we're going to figure that out and use another command to do it all the way around the site for us. So, but I know that there's a, uh-oh. I know that there was a little issue up there in that corner, just from being familiar with the file before. All right, so it looks like this is going to follow around correctly all the way around. We lose the backside over here for that set of 17s, but it looks like so 10 either this segment goes from 52 from 11 to 52, or it goes from 10 to 17. And this is really should have been drawn up a little shorter. Maybe there should be a little step away out here. I'm not sure exactly where that would be. I'm going to assume it's going to look like this. So 51, 50, 51, 52. I will continue that to there. So that could be what's going on.
Hey, Ken, I have a question.
Yes.
If we had it set up that when the software drew it, it connected all the 17s, right?
Mm-hmm.
Do those lines act as break lines too? I
Yes,
mean, I know they're poly lines connecting the points, but do they act as break lines
they
also?
are. They are, and they, as long as they're there and as long as they have um elevation, which you can see because I just spun this up here. You see, hold on. See how that has, they are at elevation, then they
Yeah.
become, when I select them to triangulate and contour, this barrier in between here keeps, say, point number 343 from looking across and seeing point number 56 and deciding that that's where that triangle edge needs to go. Because that's what happened in our,
Okay.
yeah, in our in our model, because you see here we've got what, see, we're supposed to have a line right through here because that keeps this point from looking down and seeing this other point. And so without that line, it assumed that change, and that change didn't really happen.
Okay.
So it really, maybe here's a better place to illustrate it. It should go from uh, say here across to here, which would keep this line here from forming. And so that's exactly what we're doing, is we're going to have the system create these sets of lines, and then maybe we'll do a little bit of editing over here. So, but we get a sense of what our point numbers and things are going to be. So I'll go from point 10. I've got a 10 to 11 to 12. And if I follow that all the way around, you see it's going to come down to at some point, there's 47, 48, 49, 50, 51, 52. So I'm going to now erase by layer. I'll hit the clear button, select from screen. I'm just going to take these out of here. And so if I go from 10 to 52, that should finish my 17s. And let's see what that does for us. So if I draw a 3D polyline on top of the bank, I'll say okay, and I'm going to say 10 to, what did I say, 52.
2.
All right, so what did that do? That went, all right, that looks like it's
Pretty well top.
very nicely copied that top of that bank, okay? Now, I've got this outside bank from 158, 57, so it's going the opposite direction. So let's find where it starts around over here. There's this ground, there's 17, so 127, 128, 129. So 127 coming around to 158. So I'll repeat that again. So 127 to 158. See what that looks like. All right, nice. We didn't cross anything there. We got the points down in the middle. And so now what are these points? So there's an 84, 85. Is this an 83? No, yeah, there's 83. So that would be the inside. So 83 all the way around to up here is going to end with 94. And that would be this inside, which would be 53. So 53 to 94. Uh, 53 to 94. All right, that's one. That would be the bottom of the bank that's closest to the inside top. All right, so that looked pretty good. And what's the other 18 is 95 all the way around to probably over here at 126. '95 to 126. So I'm going to repeat my 3D. 95 to 126, did I say? Yeah. All right, so what does that do for us? And we now also have these ground shots out here, so they can no longer get, see, that ground shot can't look across this line and see a point over here, for instance, okay? It's going to get stopped by that break line. So what do we have? Looks like everything's following. Do we cross? No, because we can't cross any of these. All right, so that's probably okay. Now, one of the things that I would suggest is that this line, probably he missed a, whoever surveyed this maybe missed a point over here. So we could interpolate that point to be between this elevation and that elevation. You get the idea. We're not going to waste any, a whole lot of time trying to make a silk purse out of this particular sow's ear, but we'll
Hmm.
go up here and maybe get rid of this one segment, or I'm going to highlight that. I'll grab that grip, which is 9.57, and let's put it back there to 9.7. So we'll keep that like that. So with the exception of maybe a couple of little things in there, maybe something in there, we don't know. Now, so we're going to recreate this surface file and see the difference. Now there's a couple of things going on here. Let me change.
Somehow in doing that, I somehow must have put a plot way down in the corner here because I went to do my extents and it like put the machine way up to the right.
Okay, so if
So
you
I
do
have
a zoom
no idea what
extent,
this
it
is.
went something like that.
Yeah,
Okay. Point, if you can see that, point to it with the mouse and use the wheel to zoom back into it,
into the flyer or to the actual.
into the main bunch of data.
Okay. And there was something about ignore all others we did yesterday, right?
Well, it was this. We're going to go to edit, erase, erase outside. And you're going to just click a point down to the left and click a point up to the right.
And
And
then
then
hit enter.
extents and it should fix it.
Perfect.
Okay. Now, here's something else I want to show you that you've got as an option for these surface models. And this gets more into the finessing of these models and how they should work. Let's go back now. If you've got your lines drawn and your points are there, let's go to the surface menu and choose triangulate and contour. We're going to take the same settings that we've had here. We're going to leave the file. It's going to ask if it's okay to overwrite, which it will be. But I'm going to do a couple of things here first. I'm going to draw, I'm going to go to the triangulate tab, and I'm going to draw the triangulation lines, and I'll just leave that on that layer, TRI lines. It doesn't matter what layer it is, you're going to see some magenta colored triangulation lines are going to get created. I'm going to do that just to run this a couple of times to illustrate a point. I don't generally do this in terms of production work, but I want you to see what's going on. All right, so I'm going to do that and say, okay. Is it okay to overwrite? Yes, it is. Now select the points and break lines to triangulate, select entities. So I'll grab my data and I'll hit enter. Oh, I should have turned the contours off. Actually, let me go back and do that again. Repeat triangulation. And I'm going to go to contours and I'm going to uncheck draw the contours. There we go. I'll say, okay. Yes, it's okay to overwrite. Get the data. And there's what I want to do right now. These are all of the edges of the triangles that formed. And if you notice let me select all of these and I'm going to put them in the back. So if you notice, those yellow and blue lines were my top and bottom of the bank. And you see how now this point here, this ground shot point, is prevented from looking across and seeing this ground shot point because this line and this line and this line are all in the way, okay? But if this line here, this yellow line is in the way, the only place it can find another point is to go way down here and find this point like there. And then it comes way back here and finds this point here. Well, that's okay, and that still might be very valid, but if you get these triangles might become, really long and they're pretty sparse in between. In fact, let's take a measurement to see how long that distance is. So I'll go to my inquiry and choose standard distance, and I'm just going to go from, I'm going to get out here beside it, and I'm just going to go from there to there, get a sense of what that is. That is almost 100 feet. Okay. Now, here's what, here's another switch that we can use. I'm going to choose erase by layer, clear the layer list, select from the screen, select my triangle face and get done. And now I'm going to run the command to triangulate and contour again with another switch turned on. And this is on the triangulate tab down here at the bottom where it says dense, or toward the bottom, it says densify break lines. I'm going to turn that on. And I'm going to put that, say, every 20 feet. Now what that's going to do is it's going to read all of this line work, and even though they only have a vertex at those discrete point locations, it's going to, in memory only now, it's going to add a point every 20 feet so that those triangles can then use those to make a little smaller, not quite so large and splayed out triangles, which would help to smooth the modeling a little bit. So I'm going to leave that on now and say, okay, I'll leave everything else as is, gather my data, and then we'll take a look at the difference in those triangles. So now, see here how if I take these and set them to the back. So now, even though, see this yellow line went from 0.133 to 0.134, and before we densified this 0.179 made a triangle from 179 to 133, all the way back to 134, and then back to 179. That was one triangle. But because we densified this in memory, it put a little temporary point there, and it was just as if we had those points inside that line work.
So why did it only do it in the ravine then? And like at the very extent there to the left between 0.179 and 180 on your screen, that's just a
Yeah.
long line again.
Well, because there's no line out there. Okay. If I do let's get rid of those triangles again. You see, they're just points. So we could, that's a very good question, by the way, and that's going to go from say 161 to 261.
So we didn't actually have it drawn, so it was just kind of connecting the dots and leaving it
61
there.
to 183. So let's do that. Let's say 161. What was that other 184? All right, so that, yeah, see, that looks
Funky.
like it. In fact, I may, yeah, I may do something like that. All right, and so now, if
You
you,
put that as a top or bottom for that line you're drawing.
I,
I didn't see that.
whatever it happened to be, that is on the bottom of the bank. It really is not. And see, it's just a ground shot. It's not really identified as like these others have a code that we recognize were those features. These are just some points out in the field. So they probably should not be connected, but to illustrate the point, because you were asking about that, that is, you know, that's the outside extent of our data, except we have this other one that's way out here on the side. So now if we triangulate and contour, leaving everything again the same. taking all of our information. Now you can see, and see there was that one point there, and then there was that line we added, and it did it every 20 feet. So it's now got a bunch of these going on. So it's a nice, and there's, you know,
Good density now, yeah.
now there's a little bit of stuff back here. You got these long skinny triangles because there's a little bit of a cut in. So I'll show you how to fix that now. So let's go to the and say okay. And now, so it doesn't really, those little things probably wouldn't make much of a difference, but in the case of something like this, oh, hang on. Oh, here we are. So in the case of something like this here, you can see, you know, they're quite obvious. We were really shallow, and so it really wouldn't make a whole lot of difference. But there's a real quick way of fixing that. And it's that thing called shrink wrap that we turned off in our command. Now, it used to be we had to draw it. We would say draw shrink wrap entities, and that's on the draw menu, and it's always still there. Or you can do it in the modeling command, triangulate and contour. There's a couple of ways to do that. You could, and once you drew that with the shrink wrap command, you could say use an inclusion and exclusion area. And when you select the data, it's going to ask you to pick the inclusion triangle or the inclusion polyline. You would pick that boundary. And so it would know to limit it to the footprint of that boundary. But the other, another method is to, instead of using that, if you come down here and use these maximum edge lengths, 2,000 feet, if I looked at those triangles and I saw that they were all, you know, say 300 feet long, I could give it a distance. Anything longer and skinny like that would get cut down. It's not, you know, totally accurate to be able to fix things. But the real thing is to shrink wrap. It's as if I've taken this data set and I go to say any given point out here and I start to it's exactly what it says. The shrink wrap is it's like you put a big piece of plastic around it and then put the hairdryer to it and it's sucked it into as tight as it needs to be to fit the data. So in a case like this, you see this slight little dimple right in here. Well, it would pull that in here. So this edge itself would work as part of that boundary until you get down to here. Then it needs to jump over here to this line, come down, then jump out here to this line. And instead of having to try to figure out how to create, and then it comes down here and it would jump down here to this outer corner and jump across. So instead of trying to create all that stuff manually, we have that command called draw shrink wrap entities. And so there's a couple of ways of doing it. You use it across gaps, bounded line work. We're going to go across gaps because we had some empty points out here. And we're going to put it on a layer name. We'll call it BDY-10. So that's a boundary for our 10. And we'll do a perimeter reduction of, say, none. We'll use a polyline of a 2D polyline. So this is a case where it can be 2D as opposed to break lines, which can be only one, or have to be 3D. All right, so now I've got this new layer. I'm going to change that to be red, and it will be, let's say, 4/10. And I'll make sure I've got my line weight on. Okay, so Now, you see, I've drawn this and I did the reduction. I said none, and that means you can see right here. It went out here to 84, but then it scoots all the way up here to 88, and yet these points are a little further in, so it didn't shrink wrap. It didn't pull all the way into that because it did no reduction. So that would be a case where if I were to triangulate and contour, I'll leave everything like I had it before, and I'll say okay, and I said everything. Now watch the triangles right in that area. See how it made those long skinny triangles in that part in there? So,
Mm-hmm.
so that part is invalid. Now I'm going to erase those triangles again. And let's fix this. Now I could do it a number of ways. I could, select that and say add a vertex and, snap to these corners and do that all the way around, blah, blah, blah. I'm not going to do that. What I'm going to do though is when I run this shrink wrap command again, draw shrink wrap entities, instead of having none for my perimeter reduction, I want to put in, say, um, maybe a high reduction. And we'll talk about what that means when it says perimeter reduction. We'll talk about that in just a minute. I'm going to say, okay, I'm going to draw my boundary, and there it's gone around and it's chopped in pretty tight. And you can see now it follows all along those points. Okay. And it even gets over here. Now here's where, well, maybe I would want, maybe I would want this to be a little less severe in that particular area. All right, so that might work. And then, so it doesn't have to tighten up quite so tightly around that area. So maybe that would be, a valid way of doing it. Now, what it's asking for when we do that command, when it says amount of perimeter reduction, what it's doing is it's actually triangulating the data just like we did before, and is generating those long skinny triangles all in memory, and then it's looking at those triangles around the edges. It starts on the outside and works in. And it says, how much of those outside triangles do you want me to reduce? When you say none, well, it keeps all of the triangles. Again, it just does it in memory. And then draws around the outermost edges of those triangles. If you said a high reduction, that means take those triangles and look at those, but I want you to be, really aggressive in reducing those outside triangles so that, give a high level of reduction. And there's no particular way of, having, we don't really know what's exact. We just have to sort of, look at it and say, well, that makes sense, or it doesn't, kind of thing. In fact, I may even do something like this. Yeah, that probably will give me what I'm looking for. All right, so now, and that's the way that I typically do this, was I draw that thing first, and then I'm going to go back here. Let's go back to the surface menu, triangulate and contour. And this time, because I've drawn this, and it is a closed, let me cancel that a minute, I'll select it and look at the properties. You see, it is a closed, right here, yes, it's closed, polyline, and that's what it needs to be an inclusion polyline. So if I run my triangulate and contour again, and this time I say use my inclusion exclusion area, and I'm going to use that to trim any of that surface off at that boundary. If I said remove crossing edges, it would not just trim the triangles that extend past it, it would remove the entire triangle if even a part of it went past it. So that's my preference, is to trim them. Now I'm going to do it that way, but notice if I didn't do that, and if I did not previously draw that shrink wrap boundary, now, and I say now meaning previous versions did not have it here, but now this command allows you to use shrink wrap perimeter reduction, none, low, medium, high. Let's say we did a medium reduction and we went to setup, and you have the option to draw it or not, yes or no. And even if you didn't draw it, but you just used it, it will calculate all of that stuff in memory, apply it as the boundary of the surface, and fix all that for you. Okay, so you don't have to pre-draw it. I like to do that because I like to see it and make little decisions about tweaks. And so once it's drawn, I'm going to use those areas, and I don't have to draw it inside. So now if I do it, and I say, okay, now look at the prompts, and they're different. It says select entities. You might have become used to it saying that, and you're going to try to, um, window everything and grab, but that's not what it's asking for right now. Right now, because I changed the switch, it says select the inclusion perimeter polyline. Aha, that's that red guy. All right, so it says, and it can be more than one, because you can have, it can be non-contiguous parts of a surface. So I've selected that one. It tells me entities in set one, and it keeps prompting to select entities. When I'm through selecting, I'm going to hit enter. So I'm through selecting that type of entity. I hit enter. Now it says select any exclusion polylines. Examples of which might be, building footprint or ponds or something that you don't know what's underneath the surface in that particular area. I have none. I'll say enter. Now select the points and the break lines to triangulate. So now I'm going to grab everything. And I'm through selecting that. I'll hit enter. And you'll still see the triangles draw, but you're going to look up here and see there are no longer those little skinny ones in that area. Got a couple maybe right in there and maybe over in here. See, in here we've got some as well. I don't, nothing really came out here because it's not, this red line that we drew, the shrink wrap, is a 2D polyline, so it has no elevation. So it's not used for anything other than trimming off the triangles. Okay, so there's that. If I wanted to, and you see how all these triangles are sort of regular space and they're not right in here? Well, what could you do, for instance, if you wanted to see them through there? Now, these are probably valid. I wouldn't say that that's going to cause any problem, but what could normally, if you saw something like this with the triangles of the surface, what about if you drew, let's do this. Let's go back to, all right, so if I put this in as a break line, and then redraw or recompute, this edge could not form because it cannot cross that line. This edge can't form because it can't cross that line. It can come down from this point to somewhere along this line and stop, but it can't cross it, okay? Nor can this, nor can this. So what's going to be the effect of that? Now, again, that's probably, there's no need to do that, but you can see the difference once we recompute. So now I've got this new line in here as a break line. And here's my inclusion. No exclusions. All data. Now you see how the triangles weren't allowed to cross. I'm going to select one of those. I'm going to select similar. And I'm going to draw order to the back. And when you see these menus pop up, I'm just right clicking the mouse. So because I use that as a break line, that forced those triangles to come along that line, okay? So now one last little trip, and I'm gonna run triangulate and contour again, but this time I'm gonna turn off those draw triangle lines. I'm gonna go back to contours. I'm gonna draw my contours again. So I'm gonna turn that back on. I'll say, okay, yes, it's okay to overwrite. There's my inclusion, no exclusion, all data. And there now are the contours. And so if I look at these contours, let me actually freeze my bottom bank and top bank. So now if I'm looking at those contour lines, you see how they're much more regularly spaced and look much more like ditches. And in fact, if I verify this by viewing my 3D viewer, the surface that I just created, there you can see the triangles. I'll turn those off, but I'll put the contours on. And let's put these as a 1 foot contour interval. And wow, look at the difference. And if you remember what it looked like before, it had all the jumble stuff going on. And you see the difference that break lines make.
Yeah.
All right. And that's why I mean, it's important to use these things because, and I know people, I know companies that don't, they don't know how, and they, they compute things based on it, and it's technically wrong. Now, I can see up here, I would probably spend a little bit of effort or maybe not, I don't know. If I were doing some critical work up here, I would try to define those edges a little better. Hopefully, the work I'm going to do is over here, right? And now, while you're there, while you've done that, the reason we do something like this is, let's go back to the surface menu and let's do this design. Well, not yet. Let's draw. I'm going to draw a polyline. Let's call that a building pad, right? And I'm gonna see, what is this elevation is 18, all right. So here's what you would, um, the reason you would normally, do something like that. Let's see, this is 20 is, let me change that to be green, it will go up. All right, so maybe I want to build myself a little building out here or a pond or a borrow pit or something. So I'm going to outline that structure and then I'm going to go to my surface menu. I'm going to say design pad template. And I'm going to target a surface file. I'll go to the outside and I'll use a ratio. Let's see what else I want to have here. Say it's fine. Find the pin, selecting color sign. Color pad. And I think that's all I really need. So I'm going to pick this pad polyline. There's the surface I'm going to be using. And I'm going to use, say, 4:1 slopes. And I go from 15.3 to 19.7. Oh, it's 17.5. 17.5. And then what I would typically do is I would isolate my pad. I would build a surface out of that. I would go to select, make this one called pad. Don't need to draw the contours yet. That should work. Select my inclusion, which is that. No exclusion and everything there. Very good. And then use some triangulation file utilities. I would load up my Mantopo. I would go next. Oops. Sorry.
You hit
Load
exit.
up my Mantopo and go next. And I'm going to merge my pad. And yeah, see, it's very slight, but it's going to be, a little bit of cut on that uphill side and a little bit of fill on this downhill side. All right, I'm going to export that. Actually not export, but save as rather. And I would just call that pad merge. Exit that. We'll now do a couple of things here. I'll restore my layers. Now that's my layers, and my other contours went away because I told it to erase those previous layers. when I did that. So let's use this to draw. I'll go to surface, contour from tin file. Okay, I'm going to use the Mantopo. I'm going to draw those contours, and I'm going to say, draw the contours. I'm going to turn the labels off right now. I don't care about that. Use the inclusion, exclusions. Everything's good. We'll go from there. We'll take the inclusion. And let's choose an exclusion of this one. So now those are my existing contours up into that new boundary. I'll repeat that same command, but this time I'm going to use the pad, and let's call that one, instead of V, we'll use C. And need any. So now I've drawn the contours of the pad. All right, so I'm going to next freeze off that pad layer. And you see there's my graded contours. I still need to contour from tin file. I need to turn that switch off. Let me see here, first of all. There we go. Now, let's contour from tin file, but this time on the triangulate, let's erase previous contour entities. Let's turn that off. So we keep the ones we've already drawn. Now we'll take that there, and we can freeze our pad layer now. And now you can see, you know, I've drawn the contours here. I've got some contours drawn that are on C topo intermediate and index, except I don't have any index. All right, so that's now that list of contours. I've also merged the surface file into this separate file, which I could have just contoured by itself. But there you can see it and see the results of that operation. Okay. So again, that's why we do this type of modeling, is we need a base that we can do this from, and we can then also take from that, go to our surface, and we're going to use our volumes by triangulation. We'll use two surfaces, and we'll say the existing surface was our Mantopo, and our final surface was our pad. And that should be all we need. Say okay, and here's now the earthwork. And it's pretty well balanced. You see, I've got a little bit more cut than fill. What, 200 yards, 250 yards, so not bad. And if I wanted to make it reach balance, right here is this line. This is, if I take that design, that pad that I designed, I need to raise it 700ths or 800ths of a foot in the air to make the earthwork balance. Well, you know, I'm not gonna bother with that, because, you know, raising something less than a tenth of a foot is going to be almost impossible to achieve anyway out there on the ground. But the point is, with all of this stuff, and that's the the use of break lines is, and that's going to wind up giving us these proper contours. We no longer have all that jumbled mess. And we did that with, using some intuition, trying to figure out what we've got going on with these points. Okay. So I'm going to save that file if you'd like. Now, I apologize. I've taken you right into your lunch, your lunch chunk, but we're going to go ahead and take it, and we missed our morning break. So, but let's go ahead and take our lunch break. We're going to come back again at 10 after, and then we'll wrap up, and we'll just sort of keep reinforcing this concept. We're going to go through that other example where we're going to build a little road alignment and a little borrow pit. Okay. So any
Sounds good.
questions at this point? Everything good?
Okay, thanks, Ken.
All right. See you guys back at 10 after. Enjoy your lunch. Our recording back on, and we'll wrap things up by going through this putting it all together workflow. Now, there is, prior to this, in the training manual, there's this section about adding break lines, this exercise here. Again, I'm going to leave that one to you for your own work sort of offline. And it's basically the same little exercise that we went through with the little simpler data set that we just looked at earlier in the morning, but uses some different existing data. And it also talks about the problem with building a surface out of, let's say, if you got a contour map from somebody and you're going to use the contours that they have to build a surface. And that's sort of a kind of it's like taking a photocopy of a photocopy of a photocopy. You keep losing information if you don't have, all the information that's in the areas where the contours aren't showing. And it gives you some idea of how to treat those kind of places and how you'd have to add break lines in. For instance, if you look at these contours here, if you tried to build a surface from those, say going down this ditch line on the edges, you would need to put those break lines in those locations to keep from getting these flat triangles in there, or you would use a switch when you're building the surface that is that says to minimize flat triangles. So there's that as an option that you could use. And so that this little exercise steps you through all of those kinds of different things and talks about how to use the 3D viewer. We've talked about that as well. So if we go through this exercise here called putting it all together, we're going to sort of start to tie together a lot of the different tools that we've looked at and how we can use those to help bring about this model. So we're going to open a drawing called example 1.dwg, and it is going to be in our data sets folder that you downloaded. So I'm going to load this up. And I'm going to choose, once this comes back to me, I'm going to choose to open files. And I'm going to navigate on my system to drive C, Carlson projects, and this is wherever you put your data set. I've got this fundamentals class, and I've got a data sets folder, and it's right here, example 1. So when I open this up, you're going to see a bunch of points. Now, it's also going to tell me that it's using a projection system, this Alabama And, you know, which one do we want to use? And I'm just going to, I'll choose this 2011. It doesn't matter at all. These are, the file is set up to use that state plane coordinate system. But if I look down here at the bottom of my status bar, I see my coordinates are on the order of, you know, 8,000, 4,000. So I'm nowhere near those coordinates. So it doesn't really matter what you answer to that prompt. So, but if I look at that, I'm going to double click the wheel on the mouse to do a zoom extents, and I see, all right, I got a bunch of points in my drawing. Okay, I've got some that have a letter B, 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 and then I've got some around the outside that say B dash toe. Okay. So if I were to try to use these points to build a surface out of this, and this is a little stockpile surface, what would be, you know, something that I might need uh, to do to help build this surface? So a couple of things. If we just are going to use the points, then what's going to happen up in here in this sort of cut in area that you see right in here is I'm going to see these long skinny triangles are going to form in this area up here, and they're really not valid because I don't know what the ground is actually doing in there. So I'm going to need to have some kind of a boundary around my outside points. Okay. Same thing, this little area down here where they scooch in, and one up here in the left. So I'm going to need to at least come up with that, and I can do that with my draw shrink wrap, or I can do some other type of tool. So we're going to play around with that. So the first thing to do is let's consider these points. I've got a point description of B, and I've got a point description of B dash toe. Okay. So I might want to draw a line through all these points that say B dash toe. And if I look up here, say starting in this arrangement, let's see, the first thing is I'm going to choose my style command. I'm going to change that PTXT to do this Calibri light. And the only reason I'm doing that is because I am the quintessential definition of the anal retentive engineer. I hate that font, so now I'm going to make them look nicer. All right, so no big deal, that totally unnecessary. So if I look at these points, I see these B toe points. I see a 2009, 2010, 8. All right, I come all the way back around. There's a 2003, 2002, 2001, 2000. And I see over here is a 2028. So I might want to look at those points and see, maybe I can just give a range 2000 to 2028, as long as they're in order and there's not something else with a different description in between. So let's take a look at these points, and we can look at them a number of ways. If you go to the points menu and choose to list the points, it's going to come up and say, give me a coordinate file. You haven't told me what coordinate file we're using. Okay. So that's a very common thing that happens, is that we might have a drawing that has points in it, but there's no associated separate coordinate file that holds the points. And we can fix that. We can take all the points in this drawing and put them in a coordinate file. Okay, we're going to do that with a couple of tools here. Let's go to the points menu, and you could see down here on the bottom, the next to the bottom command with point utilities is a bunch of pull rights and some different things that we can do with these point utilities. Now there's a sort of a nicer version of that up near the top, and it's called coordinate file utilities, and that groups them all up into a tool that lets us do various things with the coordinate file. But the first thing it wants to know is, let's get a coordinate file to process. Well, I don't have one for this drawing, which was just called example 1. So I'm going to switch to my new tab here, make sure I'm in my proper folder where my drawing is, because I opened it from data sets. And I'm going to type simply, let's call this one stockpile dash PTS, stockpile points, okay? Because, and what I'm doing that, the reason I'm doing that is to let you know you can have a coordinate file that has a different name from the drawing. It's just that we often have the same name. But we can use and switch in and out of different coordinate files. So we're going to call this one stockpile points. And it says at the top of this little tool now, highest point number, it's blank. If I choose list points and choose all and say, okay, you see, well, there's still, there's 0 points listed here because there's no points in that file yet. So how do I get the points from the drawing into a point file? And if I look down here at the bottom left of this stack of buttons, I've got the left-hand side, you see up here at the top, it says file utilities, and where on the right-hand side, it says point utilities. So these are things that work on the coordinate file or various other files. You can open up a different coordinate file, etc. All these things you can do from here. Whereas the right-hand half is going to work on just groups of individual points. Well, in terms of the file, all the way down at the bottom, you see 2 little buttons. One says update the drawing from the coordinate file, and one says update the coordinate file from the drawing. So those 2 commands are used to synchronize the points that are in your drawing with the points that are in the coordinate file, or vice versa. And right now there's no points in the coordinate file. There are points in the drawing. So I want to update my coordinate file from the drawing. So if I click that, it lets me choose a wildcard description. So if I only wanted to put B toe points in there, I could type B dash toe and it would ignore the B points, but take the B toe points. But I'm going to take them all. So I'm going to have an asterisk in there. That's my wildcard for everything. And I'm going to choose OK. All right, so now it says select entities. Reading the line above, it says select Carlson, Land Development Desktop, Softdesk, Inroads, Eagle Point, Geodometer, Leica, or Microsurvey points. So these are all those specialized points. I'm just going to grab all my points with a window. I'll finish my selection by hitting enter. And now you see up here, I've got a highest point number is 2079. If I list the points with that top button on the right and choose OK, you see now I've got points and it starts with 2000 and it comes down here to 2028. Those are my B dash toe points. And as long as they are sequential around the edges, I can use that to create that outside edge boundary that I'm going to use, just like a shrink wrap. Okay. And I'll say, okay. So I see what that looks like. So 2000 to 2028. All right, I'm going to exit that command. Now, another use for that updating tool is if you've moved some points around inside the drawing, but you have not updated the coordinate file because you didn't have your linking on, or you answered no, you didn't want to update. This allows you to take these differing locations of the same point number and bring them back into synchrony with the outside file. So keep all that in mind. If you've got points in the drawing and you're wanting them to match the points in the coordinate file, or you could have some additional points in the drawing. You've got some in the coordinate file, but not all of them. So you can bring all those together and get them to agree with each other. All right. So now we got these several points, and if we just, we're going to go to, we're going to draw that edge. We're going to say draw, and I'll just draw a 2D polyline for now, because it's just going to be a boundary. I'm just going to use it, and I'll keep it as a two-dimensional line. And I'm going to come down here on my layer where it says right now existing from whatever the last time I ran it. I'm going to call this my BDY dash TIN. That's my boundary for my tin. I'll say okay. Now it wants to know a point or a point number. Well, remember I started with 2000 and it went through 2028, and I'll hit enter, and there you see it started, worked its way around, and came all the way back here to 2028. But I need to have it finish and close up to 2000, so I can either type 2000 or I can just type this C option on my command line to close. So now I've got a closed boundary. Now I'm going to also go to my layers, and I will set this up so when we draw that boundary, you'll be able to see it a little more prominently. And I'm going to turn on my line weights and my status bar. So now there's that boundary. I could use that as a closed boundary, and that would be perfectly fine. Okay, so that's probably the quickest and easiest way to do it. Let's look at a couple of other ways to do it. If I select that boundary and delete it, what's another way that we could create that boundary that we looked at earlier this morning? Do you remember that one? That shrink wrap command? Again, it's something we want to draw, so I'm going to look on the draw menu, and I come down here and I see that shrink wrap entities. Now, there's another command right above it called boundary polyline. That's not the same thing, even though that is what we're going to be creating is a boundary polyline, but that is a specific CAD type command. And I'll show you how that one works here just to show you the difference and make sure you're not confused with it. So if I draw a series of lines, see if I can get this to change colors. Oh, let's put in a couple of different shapes here. And we'll change the colors so you can see the difference. All right, so if I were to shrink wrap this, let me make this one magenta. If I were to shrink wrap this, and let's say I also need to turn my circle into a polyline just because it's looking for a polyline. So if I were to shrink wrap this, I would say draw, shrink wrap entities. There's my boundary 10 layer that's going to go on. I'll have a high reduction. I'll use a 2D polyline, and let's choose across gaps. I'm going to say okay. And I'm going to select those things that I drew. So that's going to be from the outside in, it's going to sort of shrink wrap all the way around my edges here. Okay. So that's using shrink wrap. Now, if I get confused and if I were to say, draw a boundary polyline, now what this is And I'm going to put that on that same layer so you can recognize it. This is a means of finding interior boundaries. So if you're at all familiar with the term hatching, this is as if you're standing in, let's say these are all walls. So shrink wrapping, you're standing outside the walls and you let go a spray gun of red paint and it paints all the way around the outside edges. But a boundary polyline is going to be as if you're standing on the inside and you spin around with a can of spray paint in your hand and you're going to find that boundary between different objects. So if I choose OK and now pick up here in this empty area here, you see it makes that. If I repeat that command, oops, and say pick down here, you see it finds that interior boundary. So that's not what I want to use when I'm doing shrink wrap. I want to make sure I use that command to shrink wrap, to draw a shrink wrap entities instead of a boundary polyline. Just keep that part in mind. The boundary polyline has to do with inside out, where shrink wrap is outside in. So let's do a shrink wrap entities. And again, we'll keep it here. And we'll keep, let's turn the perimeter reduction down to none, first of all, and we'll say, okay. And we'll grab all of our data. So we're going to shrink wrap our data. But look what happened. It went from here as an outermost and it goes all the way across here to this outermost because we remember it's building all these triangles in memory, throwing them away, and it's reducing those outside edge boundaries. That's that perimeter boundary reduction. That's what that means. We said no reduction. So it kept all of the triangles that it made on first pass. So let's get rid of that and try it again. Shrink wrap entities. And this time, let's change it from a perimeter reduction of none to a perimeter reduction of high. And we'll say, okay. And let's go grab the data again. And now you can see it not only grabs, most of these things around the edges as B-toe, but look right here, it went in here and found this one. Whereas I really don't want that one to be included. I want to, because I'll go from the toe to the toe, and this is an interior point. And so I would have to sort of go around by inspection and make sure here's toe to toe to toe. Up, here's another couple points. I would select those, hover over the grip, remove the vertex, hover over the grip, remove the vertex, things like that. Okay. And it looks like, that would have fixed that as well. Okay, so that's another way of doing that. And you can do that. And once you've made those edits, that still is a closed polyline. That would be the line that you would use for
You said hover over the point and it was going to
yeah,
bring up that two options to remove the vertex. I don't see that.
you select it first. Okay, and now you get a grip. Then hover the mouse over one of the grips and you should get this pop up.
I don't.
Okay, well, then you're going to need to use the command polyline utilities, remove polyline vertex. And then you would select the entity and then you would click near the point that you want to get rid of. Okay. That grip edit is something that's available in standard AutoCAD and IntelliCAD. And if you're in the OEM, it looks like they did not include that part of it, part of that functionality. Okay. So it's just an alternate way of getting rid
Yeah,
of
no, I wasn't even able to just remove the vertex that way either. Something I'm doing slightly off.
with the Carlson command?
Mm-hmm. Well, not even the Carlson command. There's a quick link up in the top that says remove polyline vertex.
Yep.
And I select, do I have to select anything before I do it? Do I have to select the line first?
Choose the command first, and then it prompts you to select the polyline.
Okay. It
And once it's
says
selected,
select polyline to remove.
yeah, so you pick it.
Okay. All right. Got it.
Yep. So see how that works?
Yep.
Okay, good. Now, so that's one way of doing it here. Let's look at a couple of other ways to create this line. We could also, on our draw command, there is I think it's on draw. Let me make sure I'm in the right. It could be that I need to be in civil. Let me see this. I think if I draw, yes, if I come down here and say polyline, I'm going to draw and I come down to the bottom where it says polyline, and I'm looking for this polyline by nearest found. And I'm not sure if that's an OEM or not, John. I think it is, but I'm not sure where they may have put it.
I see under draw. There isn't a sub file of drop down for the polyline. It's just the only option I have is polyline by nearest found.
Okay, so that's the one we want to use. So we choose that command and a little dialog is going to pop up. Again, allowing us to choose 2D or 3D. Let's just use a 2D for now. And I'm going to put the layer again on that boundary 10 layer that I've been using. And now up here, I've got a few filters I can use. I can set a maximum distance that I want to consider. So if there's a big enough gap between the points, it won't consider that a near point. And then also a description match. And if I just said star or asterisk, which means everything, and I said okay, and now it says select the points from the screen or by point numbers. So I'm going to say from the screen, and I'm just going to grab all the points. Now watch what happens. Okay. So it goes through and finds the nearest neighbor and creates a line. So that's sort of a mess, right? We don't want that. So I'm
Yeah.
going to select that, delete it, and I'm going to run that command again. Polyline by nearest found. And this time, instead of using all of the descriptions, I'm going to put in that asterisk dash TOE, or I could say B dash TOE, but it could be either one. It just means use anything that has also a dash TOE as the end of this description. So if I choose that and say okay, again, choose by the screen, and if I select them all, it's now going to go through and do what is essentially a shrink wrap. It's going to consider all of those points and it's going to find each nearest one, but only consider the points that have a TOE in the description. Now, in this case, it worked out. It could be sometimes, though, that you might get something that it might say consider 2010 is closer to 2012. So it might go from here to here and then backtrack to 2011, something like that. In our particular case, it worked. It looks just fine. It goes
Why
around
does it not complete the poly?
because it just went from the point to the nearest point. So it didn't close it off.
Mm,
Okay. So how do you fix that? Well, remember
uh,
when you select it,
um,
look over in the properties, you can just go down to the bottom and change it from no to yes. Okay.
hmm.
Now, let's consider a couple of other things to do. So we'll use this as our boundary, and we're going to make a surface. If But for right now, I'm just going to draw you the resulting triangle so you can take a look at what is going on with the surface until we're satisfied with it, and then we'll switch it off and just build the surface. So I'm going to go to my surface menu and I'm going to choose triangulate and contour. And I'm going to look at my selection tab, make sure nothing is selected to filter out. That's fine. I'm going to go to my contour tab and I'm going to uncheck it. I'm not going to draw any contours right now. Then I'm going to go back to my triangulate tab and I'm going to uncheck this write the triangulation file. I'm not going to write the file until I'm happy with stuff. All I want to do is to draw these triangulation lines. And I'm going to check on to use the inclusion or exclusion areas because I made that boundary with that draw polyline by nearest found. Remember, it was a 2D, so it's down at 0 and the points are up at elevation. So I'm going to ignore 0 elevation entities. I'll uncheck this densify break lines and I'm going to say okay. And it wants me to select the inclusion, which was that outside boundary. It now says select entities, any exclusion polylines. Notice it's plural, it can have more than one, or enter for none, so there's none. And now still says select entities, but it's changed to select the points and break lines to triangulate. So I'm going to now grab everything. And it's going to draw that network of triangles. And it's going to go from this point to this point down to this point. So there's no densification. Remember, see, this is like this giant triangle right up here.
I definitely must have done something wrong because right now it only has like weird triangles along the outside, nothing in the interior at all.
Okay.
Let's
Let's see. Go
undo.
share your screen and let's see if we can.
All right, standby one.
All right. Okay, I think I might know what's going on here. So if you select those lines, or first of all, do this. Go to the edit, erase by layer, or choose the erase by layer icon from the layer toolbar, either one. There
This
you
one
go.
here.
Yeah. And choose select layers from screen and pick that boundary, those, one of the purple triangles. And that should be all you need for now. Hit enter to finish selecting. And okay, hit okay. All right, so now you've cleaned that off and there's your boundary. All right. Now walk me through what you did.
Well, if I remember correctly, we were talking about um,
Yep. There you go.
triangulate. We went in here, made sure this was all off. Contours off, triangulate. We turned the right triangulate off, and the density break lines off. And I went ahead and
Yep.
hit OK. Then it said select inclusion perimeter. I thought you said to select the line.
Yep.
And then hit enter.
Yep.
And then it was going to ask for select the perimeter polylines, which was, I thought, select the whole screen.
Ah, that's the problem right there. Press escape on, or no, just go ahead and click that so you've selected nothing. Now, see it says select exclusion perimeter polylines or enter for none. So there are no exclusion lines. You're not going to, put a hole in it. So you want to hit enter to select none. Now it still says select. Now's when you grab everything. There you go. See?
Mistake. Okay.
All right. So
Yeah, stop sharing.
yeah, I went ahead and took care of
Okay,
it.
perfect. Thank you.
Yeah. But I wanted you to work through that yourself. So now you've learned that. All right. So now we've got those done. So now here's a triangle, this big large one up here, because it could only find a point at that corner, that point and that point down
You're
here.
not sharing your screen right now.
Oh, sorry. Yeah, you're exactly right. And okay.
Thank you.
All right. So up here now, in this corner, you see this large triangle because it can only form a triangle where it finds that point data. And because this outside boundary was a 2D polyline down at 0, it ignored it. It's only used to trim the edges, and that's what we typically do. However, let's say we might have wanted, a little more fine tuning along these edges that we want to um, what we call densify those break lines. But the way we'd have to do that, and I'm going to go first to get rid of those triangles again by erase by layer, is I might want to use this line. I might want to, instead of having it, down here at 0, I want to have it, I've got a stray point or something down here. There we go. So I may want to have it be up so that it goes through all the elevations of all these points. So I'm going to select that line, get rid of it, and I'm going to run that command again. That was draw polyline by nearest found using that description, but this time I'm going to use a 3D polyline. So I'm going to say, okay, choose by the screen, select them all. There it is. I'm going to now select this and choose closed, yes. And so now when I look at it, I see that that line actually walks through all those points. You see some are higher, some, but the ones along the bottom, along the toe of the slope, it now has a nice little boundary around it. Okay. And what that's going to do for me is when I go to triangulate and contour, leaving everything like it is, except now I'm going to come down here and say densify these break lines, and I'm going to put a point, let's say every 5 feet, so you can tell where that goes. So I'll say okay, I'm going to select my inclusion. I'll finish that selection. It says select entities, read the line above, select any exclusion polylines or enter for none, so none. Hit enter. Now select the points and break lines to triangulate. So this time when I get the points, it's going to also choose that outside break line. And instead of now from going from this 2015 to 2079 to 2016, it in memory has put a point along that 3D polyline every 5 feet. So you see that's made these a little bit smaller triangles around the edges. Now there's no real particular benefit in doing that in this particular case, but
Out of curiosity, why does it do it every 5 feet around the perimeter versus on all of the polylines? Or not polylines, but the triangulated lines?
because there is no line information in there, so it has nothing
Uh,
to densify. The only
okay.
line that existed was along this outside edge. So if you wanted there to be, every 5 feet here, you would have to have drawn a line between those points so that it has something to
I see.
do. Now, the the and so the thing is, and you wouldn't necessarily do what we just did, but that's often something that we do to try to fine tune our data a little bit. If we have a bunch of break lines and maybe you've got a site and you've got a corner of a parking lot over here and one way over here, and you've only got those 2 points because the edge changes linearly. It changes in a constant fashion from that corner all the way down to this corner. So you didn't need to go and survey that line every 5 feet. You just get the corners. But you say, well, I want to use that line, every 5 feet along its length. but instead of actually surveying those points, I'm just going to densify it so it adds more points to my surface definition. Okay. So that's a nice little way of doing that. Now, you can get a sense of, I haven't built the surface file yet, but you can get a sense now of what this thing looks like. Let's look at it in our 3D viewer. So the view 3D view drawing viewer will take all for everything. And you can sort of see, you know, it's got some definition as a stockpile. You see all that? So that's, you know, getting to be what we're after here. Looks like I'm still in a vertical exaggerated state. So there's now back to 1. So that looks pretty good. We can go ahead and build our existing ground. So I'm going to erase by layer, get rid of those triangles again for one last time. And I'm going to go back to run my triangulate and contour, but this time I'm going to make a file. So I'm going to say write the triangulation file. I'll choose select. I'll be in my datasets folder, and I'm going to call this thing SP for stockpile -EG. So stockpile existing ground. I'm going to uncheck to draw the triangulation lines because I don't need to draw those again. It's just going to build them in memory. I just wanted to show you where they were being formed. I will use the inclusion exclusion areas, which is only inclusion at this point. I'm going to ignore my 0 elevations. I've also got these erase previous contour entities turned off so that every time I run the command, I don't want to get rid of any contours on my right. But I'll densify those break lines every 5 feet. And now I'm going to go to the contour tab and check on to draw the contours. And just for my own consistency's sake, I like to use V for existing and C for proposed. So I'm going to draw those at a 1 foot contour interval, a 5 foot index interval. I'll go to labels. I'm going to turn those labels on. And I'm going to put that, let's see, I'm going to go back to contouring and see where this index layer is this word. So I'm going to highlight that word and copy that. And then over here, I'm going to make sure that that's on the, so I'm going to, oh, sorry, I must have missed my copy. So if I copy now, oops. Okay, now paste that. So it's going to be on the VTopo IDX layer, same as down here. So it's on the same layer as the index contour, so that's fine. And let's see, I'm going to have my text size scalar 0.08, my minimum length to label 10 foot, that's all fine, but I'm going to hide the drawing under the label. I'm going to label the index only. I'm going to align the text with the contour, and I'm going to draw on the real Z axis. And instead of going at particular distance on the ground, let's change this label intervals to say 2 labels per contour. That should be sufficient. And we'll say, okay. All right, now following the prompts, it says select entities, but read the line above. So we select the inclusion boundary, and it can be more than one. It tells me I've got one thing selected, so I'm going to hit enter to finish. And now it says select entities, but it says select the exclusion polylines or enter for none, so enter. Now select the points and break lines to triangulate. So I'm going to grab everything, hit enter to finish that selection, and there it is. It has drawn my contours now and my labels. Now see, my labels look kind of chunky and big. So I'm going to go up to my settings, drawing setup, and that's if it's at a 50 scale. I'm going to change that back to a 20 scale. And I'm going to make my symbols to be 0.1 and my text to be 0.08. And then line type scale to be 1. And let's see, what else might I want to do? I might come down here and change this to 1 inch equals 20. And now you see how my text is all really crappy. So I'm going to draw or erase by layer. And this time I'm going to clear, select layers from the screen. I'm going to get one of each of those contours. So they're done. And remember, we saved the surface file, so I don't have to build it again. All I'm going to do is redraw the contour. So I'm going to go to surface, contour from tin file, and there's my file that I saved. And this is very much like the same dialog box. It doesn't have the selection filter, but everything else still the same. Labels, good, triangulation. I don't need to worry about any of that part, but I'll say okay. There's my inclusion, no exclusion. And now it's drawn it and it's made the labels a bit more reasonable for the size of my drawing. Okay. Yeah. So we've got a surface. And let's take a look at a couple of things that have happened. So first I'm going to go to my view, 3D view, surface file viewer, and I'm going to choose the surface that I just made. And here it is. I'm going to go to my settings tab, turn on my display contours at 1 foot interval. And I see right in here, looks okay, but I've got a couple of little things that might or might not really be going on. You see this business right here. I've got a low point right in here. And I've got a bit of a crease right through here. Now, with the lack of any other kind of knowledge, I don't really have anything that tells me that I should prevent this from happening across here. But if I did, I would be able to fix that in, let's see, let's also turn on these triangle edges. So right here where these contours get pulled, let me set my colors. Let's do our contour, let's see, font surface, contour color, edge color. Let's make our edge color this blue. All right, so you see how this contour gets pulled and this contour gets pulled. That means this point over here has a pretty heavy influence against this point. But if I didn't want that particular little crease to happen, I need to keep this point here from being able to see this point down here. So I need a barrier in between there. I need a break line in between there. And if I were doing that just inside this editor, I might decide that, well, I'm going to go from this point here over to this point as a break line. So watch what happens if I double click here and double click here. See how it took those contours out and it completely reshaped those contours. But now, you'd have to address, maybe that little point down there doesn't need to be dropped down into. So maybe then your break line would go from here about to here. Well, you see, you just keep chasing what they call chasing daylight. Then some people might say, well, I'm going to take that, point. I'm going to remove a point. I'm going to remove this little low point. All right. So that sort of made it. So now, so people do this and they fall into the trap of trying to make pleasing looking contours when what your real job is to do is to um, represent what's out there on the ground. Okay, so you'd have to say, I just removed that low spot. Maybe I could remove that point. You see, it's just constantly chasing daylight here. And you might come up with a nice set of smooth looking contours, but they may be completely invalid. So you wouldn't do any of that unless you had evidence. So I'm going to now exit my viewer and not save that changes. So unless you have some kind of evidence that says this contour line should just do this instead of coming up here and riding this little edge, because I don't have anything else other than these points. And I don't really have the ability to say it goes from this point up to this point in a straight line. It does not go from this point over to this point in a straight line. If I knew that, maybe because I was out on the ground and I said, oh yeah, that does that and it doesn't do this, then I would at this point say, draw a 3D polyline, and I'm going to put it on a layer called 3D-BKLN for 3D break lines. And I would go from, say, this point across to this point, and let's change the color of that to be magenta, so it's a little different. So now I could say, well, this is going to be a break line. So this point here can no longer look over here and see this point. So it's going to have to follow along those lines. Now, what happens in that case, if that break line is placed like that, so I'm going to erase by layers again, clear out those drawn contours, because if I don't clear those contours out, if I go to try to rebuild the surface, it's going to read the contours as lines. So now I've got this line, and every 5 feet, it's going to put a densification thing. So I'll go back to the surface, triangulate and contour, and leave everything. I'd say I'm going to write the triangulation file, make sure that's there, inclusion, densify, contours 1, labeled, everything's good. I'll say okay. I'll select my boundary, no exclusions, and now I'm going to get everything. And now you see that contour line that used to come over here and jump up, it doesn't do it, but I see this kind of behavior. So maybe I would need another break line, say from here to here. Okay, so there's just no real way of knowing that. Move those again, and let's go from, say, here to here now as another separate way. We'll triangulate and contour. My inclusion, no exclusion, get everything. Okay, let's go. Ah, look what happened there. Any idea what might have happened just by the looks of this? Anybody? Well, let's take a look at it zoomed up.
Whoa.
Oh, what happened? Right? I missed one of the points I was aiming for with this point. So it has a 0 elevation down here, but every 5 feet it put a point in. So that's what it did. So I'm now going to clear out those commands again, and I'm going to look at that point, and now that one is supposed to go to that, but I missed getting the drop on it. So I'm going to just hover there, pick this up, and I'm going to make sure that it snaps up there where it's supposed to go. Now I'm in good shape with that. And I'll go back now to triangulate contour. Everything's the same. I'll say select, nothing else there. Get everything. And now you see that it no longer had that little sharp thing there, but I've got a little bit of a wiggle in here. And the reason for that little wiggle is when we look at this surface, you see the contour. Let's turn this off. You see how the contours makes these triangles across here, and it's every 5 feet and every 5 feet. So sometimes densifying that doesn't really help us. We might, instead not do that. I've seen some people do this. They go to edit, a very common edit called swapping a 10 edge. So I pull down over here to swap the 10 edge. And if I do that, I'm going to double click this. And instead of this forming, it's going to form this one. And watch the contour line. See how that fixes that? Then maybe that fixes that. Maybe let's turn this one. So you get, and again, what happens is most people just wind up chasing daylight again all over the place, trying to make a good looking set of contours, and you just get ahead of yourself. So what you really need to be doing is, instead of trying to focus on what you think looks like a better, nicer looking set of contours, is just make sure you've represented the ground the way the ground is supposed to be represented. And in our particular case, we don't really know what these, whether these two things are supposed to be break lines. Made for nicer looking contours, but I'm going to take them out. I don't know that. I'm going to also erase by layer, get rid of those contours. I'm going to do it one more time. Last time, I promise. Say okay. It's okay to overwrite. I get my boundary, no exclusions. Take all my data. And I'm going to live with this as a contour that jumps up here, and that surface now I know has a break line along that edge, and that's just the way it is. Okay, because that's all the real information that I have. That's all I really know. So now, let's go about the business of creating a borrow pit. So I'm going to go first of all to my file menu, and I'm going to choose save, just so that I can keep track of this. Now, I've got a bunch of points here in my drawing. I can, if I want to get rid of them, if I make sure that my point is on a particular layer, and that's on a layer here called PNTS, well, I'm going to maybe freeze that layer. Or I could erase all the points from the drawing because I've got them in the CRD file. I'm going to leave them in the drawing. I'm just going to freeze the layer. And so I'm going to go to my view menu and choose freeze layer by pick. And I'm going to just zoom in and pick one of those red points. And you see, I can have to pick each of these little description things. And I notice I've still got that little dot that's right there. That's the actual point itself. And I click that, and now everything's gone. And if I look at my layer list, I see I had that point description. That was the description, the B dash toe, the elevation, the symbol, the point number, and then finally the actual layer that all of those things were created on. Okay, so those are all the different components of that point. So all the points are disappeared. Now, let's do a couple of other things here. We've got two labels per contour line. But let's say maybe, I don't like the way this is jammed up in the corner. I might want to, spread it out. So what was that little command that we used for that? Was on the surface menu, contour utilities, and that was move label along the contour. So I'll live with that one back there. I'd say it's okay. I'm going to select that label, that text rather, and I'm going to let it walk. Now, notice how it's oriented that way. If I turn it over here, it's going to, rotate itself around so that it reads correctly in the direction that my file is oriented. And once I'm happy with that, I'll just hit enter to finish that little command. Everything's good. I can hit save again. All right. So now I've got a surface. I've got some drawn contours. And since those are my existing contours, I'm going to change the layer symbology for those. And now I don't have a very big list of layers, but if you did, here's a nice little thing that you can do is up here in this little search field, you can say, look for particular layers based on description wildcards. So right now it's looking for everything. But if I say, look for layers that start with anything, then they have the word TOPO in them, and then end with anything, that restricts it to just those layers, even though there's other layers. So that lets me work on these. All right, so for my intermediate and my index contour line type, I'm going to choose for my index, I'm going to click that line type, and I see I've only got two line types loaded in my drawing. I want to load some more, so I'm going to come down here and choose the load button. And right now it's going to have some of these that are pre-built based on that, some defaults in the settings of these different, fence lines and railroads and right of way, things like that I have. So I might, want to have a number of those, and I'm going to maybe start down here with boundary, and I'll take all the way down here to my existing water, and I'll say, okay. So I've got a bunch of those, but I'm going to say load again, and I'm going to go over to another place and get some more because the one I'm after wasn't in there. So I'm going to choose up here instead of this file called iCAD, whatever it's called, I'm going to browse and I'm going to look in my support folder. And again, it can be anywhere. And I'm going to look for this Carlson.lin, and specifically the ones I want are going to be called contours, and I don't actually see them in this file either. So I'm going to go to browse. Let's look for iCAD.line. I'm going to look for that. There's my contour ones that I wanted. So contour and contour 2. I'm going to say okay. Now, in my index, I want to set that to contour, and my intermediates, I want to be contour 2, which is about half the length. So it's a dash pattern, but it's a specific one that's really meant for contouring. Okay, so I'm going to change the colors while I'm at it. I'm going to say for my index, I'm going to make that sort of gray. This 253 color. And my intermediate, I'm going to make 252. We'll take a look and see what that looks like. Maybe we have to bring this one back up to 254. We'll see. And I'm going to make the line weight for my intermediates, this sort of really skinny 0.09, and my index, I'll make, say, 0.2. Now, I'm going to say my MSLT scale is going to be on. My LT scale is 1, and I'm going to regen all. So there now is my contour shown as a bunch of dashed lines. Okay, now I see I've also, that's probably, I want those to be a little bit smaller dash pattern. So I'm going to select one of each of those and right click and choose select similar. So it's got all of those. And I'm going to go over to the properties and I'm going to look at this line type scale. So even though we've set the system to use a global line type scale of 1, I'm going to change these now to be 0.5. Okay, so now when I do that, see what it's done is has made the dash pattern a little tighter, but so it looks a little bit more like what I would expect existing contours to look like. And I'm happy with that. I'll go to File, Save. Now let's design something on top of this thing. If we want to put a borrow pit in here, okay. So I'm going to go to my layers and I'm going to make a new layer. So I'm going to select over here on the side and in layers, I'm going to choose create new one. And I'm going to call this pit. And I'm going to make that borrow pit green. And I'm now going to, you can right click and choose current or just double click it to make it the current layer. So now I'm sitting on this layer that I just made. And I'm going to draw the boundary of this borrow pit. And I'm going to be looking at something like that right there that I'm going to use to make this borrow pit. Okay. So I'm going to just draw for now, a 2D polyline because I'm not going to worry about trying to establish the elevation that I'm going to use another command to do that. And I'm going to put that on this layer. I'm going to say, just use the current drawing properties. And I'm just going to come over here and say, I'll start, say, like right in here. Maybe come to and then C to close. Actually, I think once I want to do that, I want to pull this in just a little bit, maybe pull this one back up this way a little more. Okay, so what I'm going to do is I'm going to use this as the boundary of this borrow pit, and I'm going to dig down into it till I get some amount of material out of my stockpile. And then we're going to build a road to come up and go into our little stockpile area. So we want this to be, let's see, I'll scooch it back just a little bit closer here. That should work. And now what we want to do with this is one of two things. We're going to use a command on the surface menu called Design Pad Template. And this is how we put grading in, how we design something at a particular grade. And we're either going to go to the outside or to the inside of that line based on, its elevation. So even though it says pad, they're not always closed polylines. Sometimes we start at a particular at a given elevation, and we climb up and out of that little pond area. But sometimes it might be the top of a building pad, and it's going to have, cut and fill based on trying to get back to that existing ground. So it could go to the outside, or in this case, it could go to the inside. Now, if this is going to be our borrow pit, and if it represents the floor of our borrow pit, we're going to come up out of that floor that's at some given elevation and come out to the outside edges until we hit that existing stockpile. But if it is the top edge of the borrow pit and we're going to go down inside it from here, then we have a little bit different scenario. We're going to need to set this either at a specific elevation, or we're going to need to drape it along that surface and then take that line and project it down until we hit a flat bottom elevation. So now that particular task to drape something on the ground, and see if I can find where it might be in survey. I know in civil, it's on the 3D data menu, but we're also going to be looking at creating this as a three-dimensional polyline and let it pick up the elevation of the surface as it goes along its route. In civil, if I switch to civil, it's simple. On the 3D data, I would go to this 2D to 3D by surface model. I would simply pick it, and it would ask me for the surface, and it would lay it on that surface, and I'd be done. But survey doesn't have that. Survey, see if I can find an appropriate command to use, and that would be, let's see. Well, let's try this. If I make a profile, those on the surface menu, I've got some profile information down here. So if I do a profile from surface entities or things drawn in the drawing, or if I say a profile from a grid or triangulation surface, that's really what I want, is that profile from a saved surface. So if I choose that, here's my surface. It prompts me for the surface to read. There it is. And now it wants me to create a profile. I'm going to use a roadway type center line. It doesn't matter in this particular case because it's not really going to be an alignment. I'm going to trick it into creating this outside edge as an alignment. I think this will work. And I'm going to say, okay. And it wants to know a profile to write. Well, I'm going to call this my pit edge. It says polyline should have been drawn in the direction of increasing station. That doesn't matter. Centerline file or select the polyline. So I'm going to select this line. Give it a starting station of 0, 0. So it's now made a profile of the existing ground starting at this corner as it walks along this direction. So if you look at that in our profile editor, again on the surface menu, I'll choose that pit edge and you see the preview of it there. I'll open it and there it is. And you see right here at the start, it has an elevation of 401/1963. We come back around to the end, it's 401/1963. So it's followed the existing ground all the way around it to create that definition of the surface along that pathway, okay? So I'm going to select that original 2D polyline. I'm going to make that this sort of dark blue, just so I can hang on to it. We can see the difference when we do this next little trick. So I'm going to go to my surface menu and I'm going to go from profile to a 3D polyline. So when I do that, I'm going to put my layer name. I'm going to set that on pit. And again, I'm not worried about the curves, but I'm going to say okay. And it wants me to select the center line, which was here. Select the profile that corresponds to that we just read. We'll say that. And now do I want to erase the center line? I'm going to say no. I'm going to keep that original blue. And let's see. Yep, it put two things there. It made one of them is that original down at 0, but this one you see actually rides the ground. See how it did that? So I drew that profile as a 3D polyline into my file. You can also see that in our 3D viewer. Let's give it, again, some exaggeration. So you see what it did is it went all around and made this thing lie right on the ground. Okay, now I'm going to use that to dig down into this and create a bottom to this borrow pit. So I've got an elevation here of 395, and then it goes up to 400. What is this? Probably the higher 404. So go up to 404, so 395. So if I go down to about 390, let's say we'll go take it down to an elevation of 394. That's going to be my bottom. So let's try that. If we go to surface, design pad template, and let's figure out a couple of things to do here. The source of our target surface model is either a surface file. Now that would be the case if we were, say, designing the bottom and coming out. So we're going to target the surface to quit our slopes. But we're going from the surface down to an elevation, okay? Now, what is the slope direction from that closed pad? Well, this time it's going to be to the inside, and my slope projection is going to be perpendicular to my slope direction, which gives me the more conservative approach there. And I'm going to use a ratio as my design slope format. That means when it asks me for the side slopes, I'm going to put in like 2 to 1, 3 to 1, that sort of thing. Different colors if you want to use and build these surfaces. I'm going to just take those defaults as they are. I'm not going to calculate volumes or do any of that kind of stuff at this point yet. I'm just going to generate the three-dimensional geometry to make sure it's going to work for what I'm trying to do. Okay. So I'm going to round any exterior corners. I can erase any previous pad entities. So if I run it again after I change something, it will clear out the old ones. That's fine. I can draw these side slope polylines, and that's these little connecting lines that are going to go down here, and they're just going to indicate the side slope. They're not necessary to have, but they're there. And I'll put them every 10 feet. I'm not going to do any contour trimming, any of that kind of stuff at this point. You got shrink and swell factors, subgrades, and topsoils, and all that kind of stuff. There's your pad layer, and I'm going to call that pad to keep it separate from pit, just so that it doesn't get rid of our original if we go to erase them. All right, so I'm going to say okay. So pick the pad polyline. I'm going to pick that 3D pad polyline, and I'm going to use, say, 3 to 1 if I'm in fill and 3 to 1 if I'm in cut. And the surface elevation, the target that I want to use was that 390, what did I say, 4? Let's say 394, let's say 394.5. Okay. So do I want to adjust and redesign? Let's just say no. And let's take a look at what this looks like. See, it's really irregular because this is irregular at the top, but it's going to look like this. Let's maybe cut this down to 2. So, you know, it would, it's hard to get a sense of it. With just those contours. Let's add the surface. Let's make that a bit more opaque or a bit less opaque. It still doesn't quite give us what I was looking for. Let's see. There, I'm up looking underneath it. I can see it a little bit better. So that would be how it would cut down into that area. Excuse me. But you see, it's really irregular out here. It's not a typical way we would do a design pad. Now, you could try to figure out what, you know, what the volume is and all that kind of stuff. And these edges up here are going to be nice and even on the ground, but they're going to go up and down. So let's do a little change in our approach. So let's erase by layer. So edit, erase by layer. We'll clear, then we'll select layers from the screen. I'm just going to select one of those blue lines. That was my pad layer, and I'm going to say okay. Now this, there are two things here. There's a 3D poly and a 2D poly. So I'm going to take that 3D poly and I'm going to delete it. And I'm going to take this now as the bottom of make that yellow. We're going to take this as the bottom of our borrow pit, and we're going to climb up out of it into the existing surface. So if we set this elevation, you can either set it now over in properties, or we can run this command surface design pad template. This time, instead of going to an elevation, we're going to start from an elevation, but we're going to go up to a surface, and we're going to go to the outside. Okay. So we'll say okay to that. We're going to choose our pad polyline. We'll choose our surface. We're going to give it those same slopes, 3:1. I'll hit enter. I'll hit enter. And now it says pick an elevation. And what it does is it looks at the elevation of the surface that you're using all along its length, and it shows you, it says the range, read above, the line above says the range of existing elevations along the pad goes from 395.45 to 403.6. So, so instead of, and it can be that lowest elevation if that's what you want. So everything is going to be in cut, or it could be something like 401. It can be 425, so it's all sitting up high in the air. But it's just reading you the range. It offers you the lowest. So let's keep it as the lowest that's there. We won't go any lower than that, because we can use that to help drain the bottom of the pit, and it will drain out onto the existing ground and on down out of the stockpile. So I'm just going to hit enter because that's what's in my angle brackets. So that's what that looks like. And it's going to generate the cut and fill necessary to create that. And in this case, it's all cut. So all my lines are red instead of whatever my other color was, blue, because I'm taking this now as my elevation, and I'm climbing up out to target this surface here. Okay, so do I want to adjust any parameters, redesign? I'm going to say no. If you say yes to that, it's going to ask, it'll try to balance the cut and fill and all that kind of stuff. But here's what it now looks like if I do that same thing we just did. Let's add surface to it. So now it's going to be like that, and it's going to be, if you can't really see it very well, but you see it cuts down into this flat bottom. Okay. So that would be that flat bottom, and then this would be all at that 395.45, whatever it happened to be. All right, so how do we deal with that? We need to make this into a surface, the actual borrow pit. We're going to make that into a surface too. Now remember, we made the stockpile out of a bunch of points. Here we've just got a bunch of drawn lines. Now let's isolate that layer. So we'll go to view, isolate layer. I'll pick one of those red lines. And now that's everything that's in that layer. If I look at that in my 3D viewer, you'll be able to see it a lot more clearly. And you see that indeed it's this nice little sort of bowl shape with a flat bottom. And you can make those bottoms have slope to them, or you can leave them flat, that sort of thing. But that's what it would do with 3:1 side slopes to cut down into that. All right, so I'm going to make a surface out of this by itself. And I'm going to call that my pit surface. So leaving this isolated, I've got everything I need. I've got a closed polyline around the outside edges for my shrink wrap boundary. And then I've got all of this geometry. I've got these side slopes, which again, I don't even really need. I've got this and I've got this, and that's really enough to define the surface. All the rest is just gravy. So I'm going to go to surface, triangulate, and contour, and I'm going to uncheck my draw contours. Oops, sorry. All right, so instead of, I'm going to go to my contour tab and uncheck to draw the contours. I'm just going to make the file, and I'm going to come here to the triangulate tab where it says write the triangulation file. Now, instead of leaving it what it was and overwriting, I'm going to choose select, and I'm going to make a new file now called pit. I'll use my inclusion, exclusion, densify if I need. I'd say I don't need it quite that much, but I think we're in good shape even if we don't. So reading my prompts, select the inclusion polyline, no exclusions, hit enter. So now select the points and break lines to triangulate. Notice there are no points other than the endpoints of all these little line segments. And the line segments act as break lines. So that, for instance, the point here at the end of this line can't, it can't, or say the point at the end of this line, it can't look down here and see this point because these lines are in the way. Okay. So now I hit enter to finish that, and it built it. It tells me that right in the triangulation file, everything's good. I can view that surface file, and you should see it very nicely. That's what it would look like. Let's set my exaggeration back down to real life. So that would be what that would look like. I can go to model, and I can even add the existing ground and see what that looks like. Let's make it a bit more opaque or less opaque. And let's make it not quite so less opaque. We'll see a little bit of it. All right, so there you can see the original, and you can see, down underneath is what is actually going to be cut into that ground, but it's a separate second surface now. Okay. So what can we do with that second surface? I'm going to go ahead and turn back now my view, restore layers. So what do we have? We've got two surfaces. What can we compute from those two surfaces? Anybody?
Volumes.
Yeah, exactly. The earthwork volumes. So we're going to do that with the surface command called volumes by triangulation, and we'll use two triangulation surface volumes. And it's going to ask us for two files here. And the first one, we're going to read this top stripe. It says select the existing surface. So you have to consider what's going on here. The existing surface is actually the stockpile. The borrow pit is the final surface. And so if we compare those two, it should give us, a negative volume, or it should give us a volume of cut or, export. That would be the way we would approach it. However, you might want to, instead of looking at it that way, reverse the order of those so that it's going from the bottom of the borrow pit up to the existing ground. And that can, maybe you could consider that as the volume capacity of that surface. Either way, the number will be the same. So I'm going to choose this stockpile existing ground as my existing. I'll hit OK, and it comes right back and asks me for another surface. What's the final surface? There it is, pit. I'll say open. any inclusion and exclusion polylines. I don't really need to. I could limit it to this, or I could even limit it to this inside thing here, or if I had a phase boundary or something, I could, limit those numbers, those reports by boundary. But I'm going to just hit enter because it only goes out to the defined edges of the surface and they've already been constrained. So I'm just going to hit enter. And now let's see, I've got this, I want to report in cubic yards and square feet from my area. You could report tons if you knew that, let's say that was a limestone stockpile, 120 pounds per cubic foot. Get your tonnage, you know, all kinds of things you can do with that. I'll say, okay. And here now is the volume report. I've got 1,600 yards or 2,500 tons of rock available in my work. And 0 for fill, but that's for my cut. So that's how much I can get out of that particular borrow pit. And here's a couple of summaries. And it says by average cut depth of 4 feet, I'm going to be taking out 1,600 cubic yards. That's a base, that's this number up here repeated again. And it's saying now, so the elevation changed to reach balance. So if I took that bottom surface, that pit surface, and if I raised it 4 feet, that should get, that would get rid of that disparity. There's another number that it tells me there is right here, is that this is how much volume change I'm going to get out of every 1/10 of a foot of vertical height change. So the volume change per 1/10 of a foot is, 38.5 cubic yards.
That's a little confusing to me, that specific um, number there, because if it's changing by an increasing surface area, it wouldn't remain the
You're
same per linear foot.
exactly right. So, but what this is when it does these numbers,
Uh-huh.
this area in cut, it takes it 10,387.4 square feet. So it takes the actual area and it now starts to
Into
create
square feet, I guess that
a
makes sense.
cubed, a cubed structure. So, and that's why it's got an average cut depth. So 4.16 feet of height over a 10,387.4 square foot. So it basically makes a rectangular prism,
Got it.
a
Yeah.
cube, and then it says if you do it. So you can only really use this as a guide. So let's say I needed to have a certain amount of tonnage that I was looking for to use over on another part of my construction job. Well, I might want to design this to get me, so many cubic yards. Let's say maybe I needed, instead of say 1,600 cubic yards, maybe I need 3,000 cubic yards of fill material somewhere else. Well, that means I'm at 1,600 now, and I'm going to, for every 1/10 of a foot, I'm going to get 38, so how far do I have to drop it to get to that number? Well, that's just sort of a bit of a guide with that report. Now, in civil, you've got a lot more tools like that. I'm going to save this just in case I put a little bookmark here. I'm going to switch to civil, and civil has this additional thing. It not only has design pad template, but it's got edit the pad template. So when I do that, it wants me to pick the pad polyline. So I pick that, and it brings up this little editing pad here. When there's my original 3:1 side slopes, there's my pad elevation, there's my target surface. I'm going to report. I'm going to process. I got to process it first. All right. So now, and that's the original that I had done to begin with. Okay. So it tells me my volume up here is 1598.6 cubic yard. But I can do things like I can move this pad. So if I move the pad, so what happens here? So I could move it, say from there, maybe it's too close to the back side. I'm going to bring it forward a little bit. And I can rotate it. So let's say if I moved it, I'm going to now process it again. So it now recomputes and you see my numbers. I'm actually got a little bit different. I could change the elevation. Let's try it instead of at 395. Let's go down to 393.25 and reprocess that. So you see now we're getting a little bit difference. Okay. So what else? Now I'm up to 2,400 cubic yards. We can also do this. If I'm going to actually, I'm going to move a vertex. So I'm going to bring these back in off that back wall a little bit. Let's see, let's move vertex. So I'm bringing it in a little bit here so that I don't go off the surface is what I'm trying to do. And one last one is I can get this one a little closer down to here. Okay, now I've done that, I can process that. But now here's the cool thing about this is, so that takes me up to 2,300 cubic yards. Let's say I need 2,500. So I can just keep guessing with this or whatever, or I can choose this balance. So if I choose balance, as soon as I get this thing to respond, I can put in, now a balance condition, balance cut and fill, you would have 0 cut, 0 fill, or 0 import, 0 export. But what I want instead of zeros is I'm actually going to target, I need 2,500 cubic yards of material. And you can give it a tolerance value here. So let's maybe say, cut it down to 5. So the nearest 5 cubic yards, I want to have 2,500 yards of material to haul away. So I'm going to say, okay, it's going to recompute all of that information. Look up here at the top of my report now, 2,502.8 cubic yards. And it has to be at this bottom elevation of 392.85. Okay. So I could exit this at this time and rebuild that surface, or I can go from right here and choose write the 10, and I'm going to write that as my pit, and I'll replace it, and now I can exit it. Now I'm going to freeze, so I'll go to view. I'm going to freeze the freeze my 3D geometry. There's now there's the actual bottom boundary of that pit. Okay. So what can we do with that surface now? We've got the volumes are what we're looking for, 2,500 yards. We've got 2 different surfaces, one existing ground, one called pit. I can draw the contours for that other surface. So let's go ahead and do that, for instance. Let's go to I'm going to go back to survey, and we're going to say surface contour from tin file. Let's contour our pit. And we're going to do what here? Let's choose contour, draw the contours, and this time we're going to go to our different set of labels, or different set of layers rather, the C layers. And we'll just use one label. Actually, no, we're not going to do any labels at all. We're just going to let these intersect the other ones. We'll say, okay, I don't need any inclusions and exclusions. And there now is the contour, the design contours. And if I change those to a little more appealing, let's say 30, and we're going to be at a little heavier, and intermediates will make this sort of right. So there's now the contours, and you can see this contour elevation for this is 397. So it intersects this one, which is also 397. There now is this one here. So my 395 comes around, it hits this edge, walks all the way around here, comes back out, and comes back out over to here. Okay. So there's my grading plan. Now, the other thing that you could do with these particular contours without having merged the surfaces at all is, let's say you want to, and I think I've got a picture of it here. So here's a case where, I wound up in this particular design. There's your grading plan. You see the dash contours, the existing contours. There's your finished contours. But then I also did another picture of it. Over here is where I trimmed those existing contours at the edges of the pad, okay? And you can do that a number of ways. You can draw the contours for this surface again, for that existing ground. So, but first we have to erase the existing ones. So I'm going to erase those by layer. So I'm going to clear, select by layer. I'll grab those two layers. They're now gone. And now, but I want to trim the contours. I want to cut a hole in them using the outline of this pad surface. Now, two ways I can get that. I could thaw that layer pad that I froze and just choose that line that's already there, or I can go to surface, draw. I'm going to draw my surface boundary. So when I draw that surface boundary, I'm going to draw it as a 2D polyline. I'll say, okay. And the surface I'm going to draw now is pit. And so there now is that boundary. So when I draw the contours now, surface, contour from tin file, this time the original ground, go to my layers, set them back to V and V, the labels, turn them on, and V and V. And let's do 2 for contour. Use the inclusion exclusion areas. Now, when I do that, the inclusion area is out here, but there's nothing else outside it, so I don't even need to pick that. But the exclusion area is now this. Okay. So I'll finish that up. And now you see what it did is it drew the contours up to that boundary. I can now actually even select it and get rid of it. Okay, so the surface still exists in here. I didn't cut a hole in it. I just didn't draw contours up in there. Okay. I used that to finish, I just used it to trim off the contour drawing. Okay, so that's a number of different ways you can use those lines. You can also use this as a combined surface. So let's look at the surface triangulation file utilities. So I'm going to choose that. It's on the surface menu, triangulation file utilities. I'm going to load up the base 10 file, which was that existing ground. And there it is. You can see it has very similar tools and characteristics that we saw in the 3D viewer. And there's our little rotation mode. Here's our little color in the squares mode. And I'm going to now go to the next button. And here's where I'm going to do a bunch of these different things that you can do. If you have to raise a 10 or subtract a 10, raise it up, do different things to it, put in different boundaries and cut holes and all kinds of things you can do with it. But the biggest one that we usually do is this merge. So we're going to merge that pit into this one. And so I'm going to choose that, and it says, all right, I'm going to use the second 10 is inside my current 10's outside boundary, and I'm going to transition the two edges together. So this one happens to work because one targeted the other and it hit exactly on the edges. So I'll say, okay, I'm going to choose my pit surface, and right there's what that would look like. Okay, as a single composite surface after it's done. And so now down here, I want to output, the triangles that are on the inside, include the border, and the triangles on the outside. I just choose save as, and I'm going to call this SP-pit-MRG for merged. Okay, saved. Said okay, exit. I now have a single surface that is the result of this excavation, and I can view that in my viewer. Let me make sure my opacity is back to 100%. So there now would be what that would look like. And we need to figure out now how to get a haul truck up that road and into that as a borrow pit. All right. So we'll do that next. We're going to take a little break and take our afternoon break. And when we come back, let's go ahead and save the work that we've done so far. And we're going to now work on those. We're going to work on the center line. We're going to turn that into a vertical alignment. And we're going to offset the edges, and we're going to use that to catch the existing ground coming in and out and catch the bottom of the borrow pit. And we should have a finished design for this borrow pit. Okay? Questions? Again, I know what it's like. It's like, wow, my gosh, this is like, being drowned, being held under at the beach during a hurricane. I know, I've been there. But trust me, it will come. If you use these examples, study the videos, it's going to sink in and it will happen. You got to remember, I've been doing this for 40 years. All right. Well, so
Yeah.
I've done it in one, two, 3, 4, 5, 6, 7, 8, 8 different major platforms. I've done 8 different, software products. It all works the same. It's just knowing where the tools are. And that's where those, where those 40 years have, beat the hell out of me. But, but what I can tell you from that hard-won experience is that it will gel. All right. So just give it a little time, give it some practice, and you should be in good shape. All right. So it's approaching 5 after. Let's come back at 20 after. That'll give us our full 15 minutes. And we'll then finish out the rest of our day. Okay. Back on for the last little segment. Now, what we're going to take a look at here first is a couple of more evaluation tools that we have in our disposal. One of which is this cool little thing called a quick profile. If you go to the surface menu and down below here, now you got to realize the civil menu has an entire profile menu. There's a lot more profile tools, but we got a few. So we're going to look at our quick profile, and we're going to tell it now what we want to use for the source of the surface model. And if we said screen entities, for instance, and said, okay, now we can either pick a starting point or we can choose an existing center line or an existing drawn polyline. Well, I'm just going to draw from, say, here all the way across to here. Okay, and I'll hit enter to finish. And there now is that existing ground. And I'm just going to zoom in up here, just hover and use the wheel, come back down to the bottom. Let's see, let me get that back up here a little bit. And now as I move along here, you can see that it jumps between everything it crosses. So it crossed the line right there. You can see the profile marker down below, and you see where the marker is up above. It comes up here, hits that line, then comes down and hits the bottom of our little borrow pit, climbs all the way up and goes across. There's a little flat area at the top, and it comes down here to the bottom. Now, that is if we want to look at things that are drawn in the drawing. We haven't made any surfaces, haven't used any surfaces here yet, but that's, that's a handy little evaluation tool. And you can here's the actual one-to-one exaggeration. When you say fit, it stretches it to fit this window. So I'm going to exit that and come back out. I'm going to run that command again, but this time I'm going to choose surface quick profile, but instead of screen entities, I'm going to choose a surface file. Now notice there are 2 buttons down here for your source files. You can choose for the first one. Let's choose our existing ground. Say okay, and say okay. And if there's anything in that second, if you run this and if there's anything down here, just hit the second button and hit cancel to clear that out. Okay. And so now I'm going to start from, say, here, and I'll go across again to this side and hit enter to finish. And there now reads me off that existing ground. And you see over here on the right, it tells me the slope, tells me the elevation at that point, what station along that line I'm sitting at, etc. Okay. Now, let's exit that and let's run it one more time. And this time you can compare a second surface. So I'm going to use the pit as my second surface, and I'll do that same little cross. Whoops. So let's actually get over there. And so now you can see, and the first surface is the one that it tracks, but the second surface is shown underneath it or above it if it's a finished grade. All right, so it's a nice little way to evaluate that. And if we wanted to read out elevations of this borrow pit down here instead of the existing ground, we would just choose that file first, or we would use the merged surface as a single surface and let it look across there. Now, what you can do is if you have picked a series of points on the screen, when you do this, you have the option at this point now to come over here and adjust the alignment. So if I adjust the alignment, I'm going to click and it shows me some blips up there, things that I can adjust. So I'm going to just come up here and I don't have to snap to it. I just need to click nearer to this end or nearer to that end or nearer to the middle. If I click near the middle, it's going to pick it up and let me move it, but keep the same orientation. So you can see in real time, it's showing me what those surfaces look like. And I click and put it down. And if I want to move it again, I come back down and hit adjust alignment again. And I'm going to click near this start point and let's go over to this side. And I have to come back and hit adjust alignment again. I'm going to click nearer to this end and come across this side. And now adjust and I get near the middle and I can drag it back and forth in that fashion. Okay. So let's say that was going to be our line of interest. You can actually save this as a profile file. You can draw it into your drawing. So if I choose draw, I'm going to come down here. I'm going to say 1 to 20, and let's make this a 5-foot vertical scale. So it's a 4-time vertical exaggeration. I've got all kinds of things I can do with these axes and labels and all kinds of things, but I'm just going to take the default right now just to show you what we can do. I'll take that, I'll hit OK, and I'm going to come over here and draw it down. And there now is, and again, if I had changed, I could put different grid lines, different colors, different colors for the different surfaces, etc. I didn't bother to do all that, but that's an actual drawn, and you see the elevations, and it gives me the amount of, in this case, cut of 10.54, and it's got the 2 elevations, the existing ground, the finished ground, the cut elevation. Those are just some things I put into those settings. Yours might not show that. Those are things in all of those buttons that you can control and have it show you what that might be. So that could be something that you find of use. All right, so it's a nice little tool that you've got at your disposal to help you visualize some things. Maybe you can see that better. Maybe your boss comes in and says, "Hey, cut me a section across there." Well, it's really a profile. It's not a section. A cross section is you have a central alignment and then you go sections every so often along that alignment. So you get the idea. It's just, there's your tool called Quick Profile. All right. So now what we want to do is we're going to bring in a little haul road and wrap it around and bring into our borrow pit and figure out how we're going to tie that into our surface. And we'll use that with our more simplified survey tools. Understand that the civil module has some really high-powered roadway design tools, and it can incorporate, subgrades and different materials and curbs and gutters and, benching side slopes and all kinds of different things. We're not going to get into all that right now. Right now, we're going to draw a simple centerline alignment to get our roadway in. We're going to grade the road so that we can, tie it into this existing ground and come up with a finished surface for the road, and we can merge that into our total and come up with a finished product. All right. So how do we draw an alignment, a horizontal alignment. It's what's called a center line. And you can go to the center line menu and you can design the center line on the screen. If you have the numbers already, you can go straight to the editor. But the easiest way to do it is to just draw a polyline first. And then we're going to choose polyline to centerline file. We'll turn it into a centerline file. So let's do that. Let's first go to our layer control. And let's make a new layer. And I'm going to call this C-road-CL. And I'll leave it white. And I'm going to choose the center line, except that's not the one I want. Oh, here it is, CL2. It looks like a center line. And I'm going to make that my current. So I'll double click on it and I'm ready to go. So now I'm going to draw the center line alignment. And I'm going to use a couple of shortcuts here. I'm going to go to my draw menu and just draw a 2D polyline. And remember, alignments need to be 2D until we assign the vertical to it, in which case we'll turn it into 3D. So I'm going to make sure that I am using my current drawing properties. I'm going to say OK. And now what I'm going to do is I'm going to start over here near this upper edge. And oops, I'm going to straight click. I'm not going to go all the way up to the edge because I'm going to offset these edges and part of it's going to stick off to the end. So I'm just going to be just inside here a little ways. And I'm going to come straight at this borrow pit about, well, sorry. I'm going to come here straight toward it and about in here, I'm going to click. I don't want to do it quite that bad. Let me try this one more time. Pardon me. We'll draw a 2D polyline. I'm going to start in here. I'll come. So I want to align this way. Well, heck, let's just do the pieces of it. I'll do this one. I'm going to do that, repeat it again, and I'm going to draw something that's sort of parallel to this one over here. So I'm going to come say like here to here. And then finally, I'm going to go, I'll just go from the end of that one to over here. And then I'll come up into my pit. And I'm going to just tie that down. I shift right click and choose perpendicular, and I'm going to go right to the edge of that pad. Okay. And then maybe I'm going to pull this back just a hair. So it's not such an acute angle. All right. So now I've got this is a piece. This is a piece. This is a piece. Need to stitch that all together and tie it all up together as a single unit. Okay, so I've got a command under edit called join nearest. It's also on the polyline toolbar right here. And it's going to give us a lot of options. We can set a maximum separation to join, and right here's there's a gap. So there's a separation that we need to accommodate for, and we can either type a number or we can pick, and let's say we just pick enough to get that covered. So that was like 15 feet. All right, and then the next thing is, what method do we want to do? If we say average the endpoints together, it's going to take the average of where this endpoint is and that endpoint is and put it like right in the middle. Or we could say directly connect, so it would put another little connecting segment in, or we're going to choose fill it with a 0 radius, so it's going to extend this line to where it intersects and then trim this one back at that point. Okay, so we'll do that. We'll convert lines and arcs into polylines. We will join only on identical layers and only with identical elevations, and we'll say okay. We'll now pick the individual pieces and we'll say enter, and boom, there we go. And now we have a single polyline that we're going to use as our alignment. Well, first thing you may notice is going to be kind of hard to drive a truck up here, stop and turn, crank the wheel and make these angles. So we're going to need some curves in here. And there's two ways of doing that. I can run a CAD command called fillet, which is over here on my modify toolbar, or it's under edit, fillet. And if I do that, I need to give it a radius value first down here at the bottom. So I'm going to choose radius, and I'm going to show it the radius that I want. I want to say a curve about that radius, which is 6.15 feet. And I'll pick this and this. And you see it puts like a little curve in there. Well, that may or may not be what you want. You might want it a little bigger than that. So you could, modify that and get those all together. However, it's easier to do this by going ahead and making the alignment, making the center line, using it with no curves, and then add the curves once you've created the alignment. So let's do that. Let's see. I want to probably pull this back a little bit off this edge. There we go. That should work. All right. So we now have a polyline. Let's go to the centerline menu and choose polyline to centerline file. And we're in our folder. What file we're going to call it? We'll just call it Hall Road. Say save. And it says, select the polyline that represents the center line. Reading the line above it, it says it should have been drawn in the direction of increasing stations. Understood. This is where I want it to start. I click there and it shows me the direction that the line was created in. If it should happen to be backwards from what you want, just simply come down here and hit reverse. All right, so I'm happy with that as it is. You can give it a beginning station of whatever you want. We'll just stick with 0. And it reads you off down here below. You see it gives you a bunch of line intersections, tells you to press enter to continue. So it has now created that centerline file, in which case you could go to centerline and centerline editor, pick the file, or you can just double click the line that you turned into the centerline file. And now you have all these different lines, and we're going to fit some curves in. So I'm going to go to that first starting line up here, and I want to fit a curve in there. So if I fit that curve, let's give that a curve radius of 25 feet. And we'll say okay. So that's now going to put a curve in like that at the front. It's about as big as we can get it. If you put a number in that's too big for it to handle, it will tell you that the maximum that it can use is, let's say, 23.67, and it would offer that. So you can adjust those as you need. So then I'm going to go to the next line segment down here, and I'm going to choose fit curve. And this time I'm going to give it a bigger radius, say of 50 feet, and say okay. And see, all right, so that's going to now come smoother around that. Maybe that's a little too big. Let's maybe cut that down to 40. So I just select that curve, I double click it, and I'm going to come in here and say 40. And I'm going to hold my PI points. I'll keep it tangential. I'll say okay. And so that's going to make it a little bit less of a curve. I'll come down here to my final line, and I'm going to need to fit a curve, and I bet I can't get much more than a 20 or 25 footer. Let's say 25 feet. I'll say okay. And there it is, and it comes into that last little bit of touchdown as a straight tangent, which is fine by me. Let's maybe cut that curve down from 25. Let's make it 20. Now, I'm going to hit save and then exit, and you're going to see the alignment redraws itself according to that design. That's a pretty smooth little alignment. And I'll be able to bring my roadway in to get into my borrow pit. Okay. Well, let's see. First of all, let's go to inquiry and look at a standard distance, and let's see about how far I am off of this before I hit the top of that cut bank is like what, 7.77 feet. So I'm going to probably need to make this roadway, you know, about a 10-foot wide road and then let it catch the side slopes, because that's going to be really tight. I really should have pulled it a little bit further away. Like, I wonder if I can do this and keep things tangent. I don't know that I can do that. We'll force the center lines non-tangent, choose the update method. I'm not sure that was right. I'm going to say, okay, I'll bring it back. Let's just make it a 10-foot wide road. So before you get all worked up about the fact I'm going to have a 10-foot wide haul road and I've got a truck that's probably 15 feet wide, I understand all that, but just for illustrative purposes, let's use this as a 10-foot wide road. So now I've got a center line, got a surface, and I don't know what the profile is going to look like for this road. I need to design it. And I want that to be the least amount of cut and fill along that alignment that I can. So what I need to do is make one profile that is the existing ground along that alignment. Remember, like we did the first line where we draped that line on the ground. We're going to go to that surface menu and we're going to come down here and say create profile from a grid or triangulation surface. So this is going to be our existing haul road. So the grid that we're going to use is this merged grid. The triangulation file is the merged file. We'll use a roadway center line and we'll say okay. Now it wants us to choose a profile to write. Well, we're going to call this one haul road dash EG. That's existing ground for the haul road. Save that. And now it wants us to select a centerline polyline or a CL file. If we type CL, we can actually just pick the file directly. Either one would work. It now found it, and it found 89 profile points when it made that profile. It's there. Nothing showed up in our drawing, but it's there. If we look at it, if we go to surface and profile editor, and we look at that haul road EG, and we see a little preview of it, we hit open, and we're going to see what it looks like right there in our editor. So here's where we start. We come in, we bounce around a little bit, we get over here to this, right at this tip is where we hit the edge of this cut bank, and then we come down into the bottom part of our surface, which is at 392.8494. That was the elevation of the bottom of that pit. Okay, so these are just a bunch of, you can see there's just little point. Every time it crosses a triangle, it sits down and makes a point there. Okay, So we're going to use that as a reference guide when we do our next design. So we're going to say exit for that. And we're going to go back to surface and we're going to choose our profile editor. And we're going to now make a new profile and we're going to call this one Hall Road dash FG, or finish ground. Okay, and so it's going to come in blank. Now, what we want to do with this is choose the type of profile we want to use. We're going to use a road profile. And down below here, we have a reference profile that we're going to use to design against, which is going to be that existing ground profile. And we're going to choose a reference center line, which is going to be our Hall Road center line. So that now is going to set this design to that center line and this reference profile. Now, again, you can see with no vertical exaggeration, there's not a whole lot of change here, but in their fit, it's exaggerated so we can do some work, okay? Now, as we work on designing this, we're going to have to put in our PI stations. So starting at station 0, 0, we're going to say, we don't know what the elevation is directly at this point yet, but I'm going to go over here to my depth and I'm going to make my depth 0. So I'm going to start right on the ground at that station. Okay. I'm going to make another station here. Let me open this up a little bit if I can, so I can see all this. Okay. So I'm going to now come to make another station. I'm going to go here to maybe station 50 and set it to, let's just make that station 50. And, oh, let's make that depth 0 as well. So it went from here and it went up to here at the top. And now maybe I'm going to come down here to 100 and, oh, let's call it 20. 120. And let's make that 0 as well. And then finally, we're going to go to the end station. Now, I can't really snap to that, but I can look down here at my reference center line and I see the station range. So I'm going to just type that number in as 1849.97 should work. Or let's call it 969. We'll make it a little bit short of that. And then we're going to make that elevation 0 as well. I mean depth rather, not elevation. So 1849.68. Oh, sorry, I'm too far out. 1849. Oh gosh, no, sorry. Wow. 184. That's a problem. 0.969. An elevate or a depth now of 0. What? 180, 184.9. Oh, I need to trim it here. Want it to 963 to 184.963. There we go. Elevation of 0. All right, so now this is what we got. So I've got a PI here a depth of 0, PI here, that's a nice high point, a PI here, which I would probably want to up that, change that value a little bit. I'm going to make that 150. And let's make that at a depth of, now notice positive number depths are going to be down into the ground. Negative number depths are heights above the ground. So I'm going to make that a depth of, let's say 3 feet. See where that, that's a little too far. Make it 2 feet. And that leaves our last slope into the pad at minus, let's maybe just make that a flat slope. Slope of 0. See, that's slope coming in. Going in and check my settings for a minute. Hold elevation, sight distance. Hold the next slopes. Hold. No, I want the slope. Let's see, that's the slope of 4.7. And then that's a slope of -1, -0.1%. So that's close to being flat. It'll actually come down into our flat spot. All right, so now we've got the PIs about where we want them, but we need to sort of make this balance. So I'm going to maybe come up here and scoot this out a little bit further. Let's call it, say, 65 feet. That's a little nicer. I think maybe let's give that a depth this time of -1 will be a foot up in the air as far as the PI goes. Now, we've got these individual PIs and we need to assign some vertical curve lengths. So if I come over here and I could type in a sight distance that I wanted or a vertical curve distance, well, I want that vertical curve to, let's see if a 50-footer would fit. Yep, that'll be nice. I'll come down here. Let's see if 50 feet will work here. Maybe not quite. Let's try 40. And then that will bring us down nicely into there. And again, looking at our vertical exaggeration, it's still nice and flat. But so there we've got a nice mathematical roadway type vertical alignment that we're going to use to create the stuff on the ground. So I will save that and exit. So now I've made that profile file. I'm going to go back to my layers and I'm going to make a new layer called 3D dash hall dash road dash CL for center line, and I'll make it this magenta color. And let's draw the 3D polyline from that profile into our drawing so we can use it to start doing our grading design. So we'll go to our surface menu again, and we're going to come down to our profile section, and we're going to say profile to 3D polyline. So when we do that, we'll give it a layer name. I'm going to choose set, and I'm going to find that 3D Hall Road center line that I used. Be a roadway. I'll say okay. It wants me to now pick the center line. I'll just use the center line file. CL file was our Hall Road. And the profile is that Hall Road FG. So I'll open that one. And now there it is. It's drawn into our drawing. We look at that to verify in our 3D space, and we see it's lying somewhat on the ground. You can see the high point there, and then you can see the low point down here where it comes in for a landing at our borrow pit. Okay, so now, how do we build the road? We've got the center line. We need to set the edge of the road. We're going to make this a 10-foot wide total road. Yes, I know that's insufficient, but we want to offset this line 5 feet one side and 5 feet the other side, and we want to push it down by a -2% cross slope. All right, so we have a little bit of a crown on our road. So how do you do that? And in standard CAD tools, we have an offset command. So if I were to go up here and say this line right here, if I just go to edit, offset, and I use the standard offset, excuse me, a specified distance or through erase layer, let's say a 5 foot. And it says, all right, choose what you want to offset. So if I choose this, pick the side, I'm going to go this side, and then I could go here and go that side. All right, so that offset those things 5 feet either side of that center line that I chose. Okay. If you try to do that with our polyline that we, I'm sorry, we take our 5 feet. If we try to do that with our 3D polyline, notice it says unable to use the selected entity. Please pick again. That's because it is 3D. It doesn't know how to offset that in standard CAD terms because it needs to be planar if I'm going to do an offset with standard CAD tools. So I'm going to go to edit, offset, and I've got all of these have to do with that standard planar things, but this happens to be a 3D polyline. So I'm going to come all the way down to the bottom and choose 3D polyline utilities. And I'm going to offset my 3D polyline. So when I do that, I get a various set of choices on how I want to do that. I can do it by interval, or I can offset something to a surface. So if I've got a graded line and I want it to just catch the side slopes, much like design pad template, I can just choose a surface as a target. It's the very same command, but you don't get the side slopes. You just get the offset line. But what we're going to do with this one is choose interval, and it's going to ask us how much do you want to offset it horizontally and how much do you want to offset it vertically. So the side slope projections will be perpendicular to the slope direction will give us the more conservative approach, I think. So
Hey Ken, can you explain the difference between those two a little bit?
the projection perpendicular,
Yeah, between polyline or slope direction and just what exactly that difference is.
exactly. Let me go over here and normally I do this on a whiteboard, but I'll do it here. If I let me just put this on this. If I have, and I'm going to look at this in, what would normally be a sort of a cross piece here. And I'm not looking in plan view anymore. I'm looking at this sort of at an oblique side projection. So if I've got something that I'm going to offset here, and when I tell it the difference between that, let me now choose a different color here, maybe that. So if I were to say, look at these contours that might result from this, you know, you would get something like this. All right, I think I can explain it with this. And then let me make these. So that's sort of, you're looking at a, you know, a slice of the roadway here, and it's, these would be the contours that it, you know, wrap around the back side, and this comes out the front side of this side slope here. So when you are creating the percent slope that you tell it you want to use, if you say perpendicular to the slope direction, that's going to make, and there we could get this thing to work. That's going to make the slope direction perpendicular to, it's perpendicular to the slope direction. That might be your 2% line. So you would say, you know, 2 feet, or a contour 1 foot would be, you know, 0.02 feet. But if you do it perpendicular to the polyline, then you would get a line like this. I'll just copy that over here, and let's put this one, say, up here, and then we'll make it perpendicular. Now I'm going to move that up to like this. So that would make it here. And so the contours then would be the contours that come off of that on this downslope. If this is a 2%, it's going to spread them out across this perpendicular line. If we're saying off the slope direction, it's going to put them off this particular line, and the distances between the contours that would result from this line are going to be closer together than it would be if we come off of this line. And so that's going to, if we say 2%, the interval is going to show up. It's not, so what happens if you come off perpendicular to the polyline, and then the resulting contours that get made from those will appear to be two slope, and you're going to get some reviewer with a scale and a calculator sitting there measuring the distance between the drawn contours, and he'll say, oh, that's not 2%, or that's not 2 to 1, that's 1.5 to 1, because it is 2 to 1 when you're coming off the slope direction, but it you know, it measures, and then he measures perpendicular to the slope direction, even though you designed it perpendicular to the polyline. I don't know, this is not, I can't really draw it real well to illustrate that. It's just, what's that?
Hey, Ken.
Yeah.
Wouldn't this be the perfect the example where you would push the road template down the center line instead of trying to create it this way?
Well, you can't do that with the survey um, tools. You'd have to have civil to be able to do that.
You have to have civil for that. Okay.
Yeah.
All right.
Now, I'd be glad to show you that at the end of it. If you, I don't know if you've got civil or not, but
Yeah, I do.
okay, so I'll show you that here next in a second. But anyway, the
Okay.
more conservative approach is to keep that perpendicular to the slope direction. So we're going to offset this line. Now, Josh, I know that wasn't a very satisfactory explanation, but what happens is that it generates the resulting contours and makes them look too close together if you do it off the polyline itself.
I guess yeah, I think I'm picking up what you're putting down. It kind of, to get a more, um, I guess, clearer picture of what your cross grades would actually be doing, you would use the slope direction. Is that kind of what I'm hearing?
Yeah, when we do the offset, we're going to push it out at perpendicular to the slope at that particular segment of the roadway. So it's going to push it out at that, say, 2-to-1 or 2% or whatever it happens to be. So if this is on a long downgrade, the 2% cross is going to be perpendicular to the slope direction. So it's going to look at that in 3D. If we say it in terms of the polyline, then it's going to uh, I wish I wish I had a whiteboard and some markers. I think I can draw it easier and I can tell about it. For now, let's
Hey Ken,
yes.
if you offset it 5 foot on each side, could you then have a separate profile for each of those edges?
Oh, no, because we're going to use that 3D offset. So that's, yeah, the good question. Do we have to then go and design a profile for those road edges? No, we do not. We could, if we offset the horizontal 5 feet and 5 feet, then we could do that and make 3 different profiles, but we don't need to do that once we get the center line. So if we go back to edit 3D polyline utilities and we offset a 3D polyline, by interval, we'll keep the projection perpendicular to slope direction. Let's see if the help says anything about that. Here we go. The polyline method creates the user specified slope perpendicular to polyline. The slope direction accounts for the slope of the 3D polyline and makes the surface between the original and the offset polylines to match that user specified slope. So if the 3D polyline is at a 10% slope and the offset slope is at 2-to-1, the polyline method would create surface slopes that are 2-to-1 perpendicular to the polyline, which makes it slightly steeper, 1.96-to-1, for the actual slope that goes in the slope direction with the effect of the sloping line. So for the same case, except with the slope direction method, the resulting slope perpendicular to the polyline is less steep, while the actual slope in the slope direction is exactly 2-to-1. Okay, so that would be our preference, is to use that by the slope direction. Okay. All right, so let's go with this interval and we'll say okay. And so now it wants to know a vertical and a horizontal offset amount. The horizontal offset amount in brackets, that's what it's asking for first. So I'm going to say 5 feet for that. And next it's going to ask me for the vertical offset amount. I can either type in a number for the vertical difference, or I'm going to type P for percent. That's one of my options there. And I'm going to say -2%. So I'm going to select a polyline to offset. So I'm going to pick that 3D polyline and I'm going to go to, I could pick a side, or in this case, I'm going to say B for both. So it's going to now make these 3 lines, hit enter to end. So I've now ended. Now let's take a look at that with our quick profile, screen entities, and let's go from, say, here across to here. And now you can see as I'm writing here, that's 1.5%, that's 1.5%. Oh, okay, maybe let's try this a little differently. We may have that figure backwards. So if I take these out, and let's do that command again, which was my offset 3D by interval. Let's choose it by polyline and say okay. Horizontal amount down below 5 feet. So we'll just hit enter. P for percent -2. Let's go here and let's choose B for both. And now let's run the quick profile again. And let's go from here to here. And now, okay. Josh, you taught me something. We needed it to be, because now you see my cross slope is exactly 2% on the cross slope of the road. So that other case would be more for when you're creating side slopes that intercept an existing ground, like a graded line, say from a toe or the back edge of a curb, and you're trying to catch the existing ground. But we want this to be exactly that percentage. So we're going to go perpendicular to that polyline. All right, so that now sets those. Now, to show you what those look like, Bert, in your question, do we need the additional profiles? No, we don't. And let's keep our exaggeration up here. We'll look at it 3, and you can see they all follow that original. You know, one is, 2% down below the other one. Now I'm exaggerated, so if I come back to 1, you can see it there. So it follows that same profile because it's reading that 3D polyline to create the offset lines. Okay. Now, where does that edge of pavement now need to catch? How do we grade that into our existing ground? We could use that same command. We could use this offset 3D and say, go to a surface. And at that case, we would switch back to the slope direction to come from here up to the surface. But instead of using that command, we're going to do this because I want to see those side slopes. I'm going to go back to my design pad template, just like we did the borrow pit, except we're not going to have a closed pad. We're going to have these open edges. All right. So this answer up here doesn't matter. We will again keep perpendicular to the slope direction because of that catch slope issue. We're going to go to a surface file, and we're going to call this on a pad layer. We're going to call this C-road-slopes. Okay, now we pick the pad polyline, this one, and because and we're going to go to this merged surface, and we'll say, let's say, let's go 2 to 1s instead of 3 to 1s. And which side now, because it's not closed. So I'm going to go to this direction. And that's what it would need to do. So it's a little bit in cut over here. It's a little bit in fill over here. Adjust the parameters and redesign. Yes, I'm going to change that to a 3 to 1 slope and see what happens. 3, 3. No adjustment for the top, no offset. Okay, so that now, kicked it way down here to the edge. It still caught it, so I think we'll live with that one. We'll say no. And let's repeat the command again now. And I'm going to uncheck this erase previous paths because I want to keep this stuff. So I'm going to say, okay. Oh, crap. pad. I'm going to uncheck erase and uncheck hide. There we go. So I'm going to say, okay, I'm going to now pick this polyline, this surface, and let's try 3-to-1s again and see. We might be, yeah, there we go. So we're cut here, we're right close to on the grade up here, and then we're still in cut a little bit as we come into there. We'll say, nope, that's good. And if we isolate that layer and look at this in 3D, you can see that would be what that road would look like as we cut that into our surface. Okay, we haven't done anything other than generating this material at this point. Okay, so to create a surface out of this, let's restore the layer, because I also want to get, I'm going to now go back and isolate the pad and that 3D polyline of the center line, because I want to get that ridge line. So now I need to put a border around this, because I do have a border around this side slope and I've got a border around this side slope, but I want to treat it all together. So I'm going to close this off and make a single continuous border. So I'm going to draw my shrink wrap. I'll put it on this boundary 10. I'll let it go across gaps. And let's do a high reduction. And we'll do this and see what we get. Oh, oh no, that's the original out there. That's fine. It just turned that layer back on. So I see the one that I was after was this one, which wraps all around that. That's exactly what I want. And now we're going to make a little surface out of that called road. So we go to our surface menu, we triangulate and contour. We're not going to draw these contours yet. We'll triangulate, we'll write the file. We're going to call this one all road. Use inclusion, exclusion. No need to worry about densifying. Won't hurt anything, leave it on. We'll say okay. And now we read the prompt, selecting the inclusions. There's the boundary. No exclusion. So we hit enter for that. And now we're going to select everything here that was within that window, making sure that we didn't get that other one out here. So we're good to go with that. We'll hit enter. And it brings us up a little error message. And it said we had a couple of crossing break lines, but they were less than a hundredth away. Let's say if we do, you know, if we made these like so, we can find that we had a little crossing break line right in here. We'll zoom to it and then zoom in. We see right in there, there's a little bit of a crossing. Let's keep zooming in and see if we can. So we got a little bit of a mess right in there that we would straighten out by doing something like this. I've got this that comes out here and comes back to here and goes around. So I've got a little bit of a double back with that edge in there. So if I look at that 3D polyline and I look at my vertices, Let's see where I happen to be. I don't remember where I was now. At some point at which it starts to go backward. Maybe it was up in there. Let me undo that accident. Yeah, here's where it walks around here. So if I need to just get rid of these two segments. So I'll erase these. And maybe do the same thing here. Okay, so now what is this? There we go. All right, so now if I triangulate and contour again, leave everything as it was. Okay, to overwrite, we pick our inclusion. There are no exclusions. And then we take everything that we've designed here. I think I got it all, yep. We hit enter, and it still gives us this one little breaking at 3/1000ths. So a little bit of a double back in here.
So when it's talking about breaking, is it that red line crossing over?
You see,
Is that what it is?
no, it's a crossing break line because it crossed itself. And it's crossing this red line right here. That's exactly what it is. So I'm going to take that one vertex, hover and grab it with the mouse, and I'm going to snap it to that location right there. So that now should fix that little error. So once more onto the breach, we find our inclusion, no exclusions, and we get our data. And now we're clean. We got a surface. We can view that surface. And you can see the contours that would result when we draw the contours. And then that would be how it gets merged into our total surface. Okay. So now again, let's restore our layers, and I'm going to freeze now the boundary and the pad that we used. I don't even really need to have these on anymore. Let me freeze that. I'm not erasing them because I might have to go back to it at some point. So now I've got a center line, and I can now offset that center line with a standard offset of 5 feet. And we're going to put those two things on a layer that we're going to call, make a new layer called C-road-EOP. We'll keep it white, and we'll give it a little bit of width here. And then we're going to change these two things to be on C-road-EOP. So there now are the edges of the road. And if we were to contour now the roadway, so we go to surface, contour from tin file, which use the haul road, and we'll, no need to use that. We'll draw the contours, and this time we're going to put those on C. I'm not going to label them. I'll say okay. And there now are the design contours of the road. You can see just like we had for the pad. And then we could, we would break out these, the contours in here. We could either do that just graphically, like breaking, we would use this and say trim, cut that contour out there. We do the same, kind of thing wherever we needed to. Let's see, in this case, we would see where this part would go. This part would go away because it's no longer going to be part of that combined surface. But what we let me put that back as that original. So what we would see when we looked at these surfaces, I'm going to load up my surface view. I'm going to look at the merge. That was the original ground. And now I'm going to go to the model tab. I'm going to add another surface, which would be the haul road. Okay, so you see that's going to be in there. I'm going to go to surfaces, set my road properties. It's fully opaque. Let's set this one to be a little less. Okay, so I've got a little bit sticking out in fill. The rest of it's going to be in cut down here underneath. But you see it's going to come in down here and, whoops, it's going to hit the bottom elevation of my pad down here. Now, what we would do at that point is go back to my triangulation file utilities. We would load up the merge. We go next, and we're going to merge into it the haul road, which was here. And so now the total surface is going to look like this. Okay, and so you can see there's a little bit of submerging in here that we would need to. We probably should have extended this out a little further into the depths of that. I think we got a little too high in there. And then we'll do a save as, and we'll just call it our.
Be quite a speed bump.
Yeah. And so now when we look at that, there's our total. So it would look like this. And so what we would normally do is maybe trim this thing back here and let that, trim that surface back. That came up to here and then drop. It's a little bit high. All right, so to fix that, and just for time in the class, we want to take a look at this. The bottom of this borrow pit is at, let's see, you do a quick profile. We'll use the surface, take out that. We'll set our first one to be the merge, and we're going to go just across here. And so when I'm over this part of it, I'm at elevation 392.849, 392.849. So when we were to look at our profile editor, let's go to our haul road FG, 392.849. See right there. So 392.849. would be what it should have been. And then we would save that, exit that, and go through that same process again, and that'll take out that little bump. Okay, so for whatever reason, excuse me, I didn't double check that elevation down there, so that's why that wound up being in that particular spot. Now, for those of you who are interested, if you have the civil module, I'll show you how you can actually push the cross-section, the template, down this alignment and then merge it into this as well. All right, so I'm going to select, let me erase by layer here. I'm going to select those. And let's see, I've got my road design now. Excuse me, I got my center line design. I've got all of that. I'm going to switch to the civil module. And I now have a roads menu. And I've got this, road network, or I can process the road design, which is really going to take all of these different tools and put them together in a single spot. So I'm going to say process my road design, and I'm going to come up here to my centerline file, and I see that it's already set to haul road centerline. My design profile is my FG, and if I edit that, you can see it's here, and I've got 392,849, so I'm in good shape there. I could, at this point, excuse me, oh man, excuse me, I'm so sorry. Let's exit that. Cancel this for just a minute, go to profiles. Design road profile editor, my haul road will open. And the existing ground is that merge surface. So here we go. That's what I was looking for. So I can see my little markers where my curves start and stop. I've got my PIs, and I can even come up here and edit, say this PI, if I wanted to pull it down a little bit flatter. Whoops, a little too much. Let's not do that. Let's see, I want to go to settings. I want to hold the vertical curve length. There we go. Now, when I edit that PI, yeah, see, I can pull that down, and that gets us nice and flat coming in here. And I can also see, if there's going to be too much cut through here, you can try to balance it and that kind of stuff. But I'll take it like this, save, exit. That's now that. And if I go back to roads, my road design, that was my center line, that's my profile, and I need to have a design template. So I'm going to create this design template, and I'm going to call it my haul road. And I'm going to edit that haul road now. Right now, I have nothing there. I'm going to say left side will display fill, right side will display cut, and that's just for the display. In this, I'm going to have I'm going to add a grade of a -2%. And let's go out 5 feet, and that's going to be called EOP. All right, so that's now going to get me to the edge of that road. Now I could go out and put another little, a little kick or a berm or something. I'm going to say cut. We're going to say 3 to 1s, and a fill would be a 3 to 1. All right, so now that's what it would look like. Now I could add after this grade here, I could put in, let's put another grade in. Let's put a little let's see, percent positive for 1 foot away. We'll just call it berm, whatever we're going to call it. So now you can see I kick up a little bit. So I've got a little bit of a little side grade down here. Now that takes care of that as far as the surface goes. And I've got all kinds of other things I can do here. I can put subgrades and get the, amount of gravel and serve cuts, and I can put curbs in. Um, in fact, let's go ahead and put a curb in. We'll just take a standard curb, concrete. We'll call it a CRB. So now we got curbs on either side. They're going to take up some room before we get to the cut and fill. So let's go ahead and save that. And we'll exit that. Now, so I've got a center line, I've got a profile, I've got a template. My existing surface, I'm going to choose to be this merge. That was the original. I've got sections, I got transitions, super elevations, all kinds of other stuff that we can use. I've got design sections. These are the cross sections. So for my design, it's going to be Hall Road dash FG, we'll call it. My existing section is going to be Hall Road dash PG. And we'll use that just to take a look at it. And we'll say now, okay. And so now, because I've got everything I need, I can set my range of stations. I've got my different settings on how I can apply those different things to that. I've got cut and fill gaps. I'm going to remove that one because it's left over from last time. All right, so go every 25 feet. Existing cross-section maximum offset probably needs to be nothing more than 50 feet at this point. And triangulate and contour, I'm going to do the triangulation. I'll not draw the contours. I'm going to write a file, and I'm going to call this one Hall Road dash civil, just so it's from a different source. Okay. We'll save that. We will no draw, say okay. Triangulate and contour, erasing the previous road entities, all that's good to go. Output to top grade, we'll say okay. And now it's taking all this and it gives me the report. It gives me a total amount of cut, total amount of fill, and what I can use to balance that. And it says my offset here extends beyond those existing offsets. That's just a warning that it was too far out from my pattern. So now here is all of the stuff that it used to create that road complete with these boundaries. And if I look at that surface, which was my Hall Road Civil, see, and the reason I get this out here is because that curb pushed out just enough to where it had to scoot down further to catch the ground because I was up a little high. And that's why that's why this is an additional amount from what you saw the last time. And that would actually, try to eat right over that side bank of my borrow pit. So I could then take that and go back to this process road design. Let's edit that template. Let's take those curbs out. So I'm going to take this curb and actually remove it. And we'll take this berm out and just leave it like we had the last time. We'll save that. We'll exit that. We'll hit OK. We'll hit OK. And now when we exit that, we see we no longer have that extra spillover. So it's going to be more like what we saw before. We look at that as our Hall Road Civil. And that would be there. We would see if we can pick up some of this extra stuff in here. You can see how that road surface actually gets built in relation to, and now you see the road is nice and even down here at the bottom. And let's do one last little bit with that and choose the surface I'm looking for. There we go. Triangulation file utilities. We're going to load that merge base. We'll go next, and then we're going to merge in the Hall Road Civil. Okay, so we got a little wee bit of a little bumpy thing there. Let's see. Yeah, the wee bit of a bump is this little downslope meeting this horizontal flat surface. Okay, so not enough to give us an issue, and we could go in there and tweak it if we wanted to.
Looks pretty clean to me.
Yeah. So we'll call this total dash civil. And then finally, we view that surface. You can see it's pretty nice. Let me turn this transparency back.
Thanks for showing me that, Ken. Appreciate it.
Absolutely. Now, there's another thing that might help as well when we do that. Let's see, when we choose this and we go to these triangulating contour, do we have? We don't have it here, but let's look at this one further. Our process road network. We got all these files. See here, what was I looking for? I want to set the colors. Let me cancel that a minute. Let's go back to road network. I think I've missed that part. There we go. So a new one, we'll just call it HR. And so over here, I'm going to add these roads in. First, I'm going to look at my settings. Existing surface was my merge, my output options, triangulate and contour. We're going to make this file civil dash net for the road net. And again, I'll leave the contours off for now. So that's good for that. Set colors layers, there we go. So I've got this grade of one color. All right, let's say okay to that. Let's see, let's add the center line and our design profile. Oops, let's exit that. Let's call it HRFG. And my design template is my Hall Road. And now let's put that, we'll go ahead and add those curbs back in. Let's use a curb like, yeah, that's fine. We'll just call it concrete and we'll call it a CRB. It's a 12-foot width. Let's see, that's 12-inch rather. 18. 1-inch drop. Let's make that about a half-inch drop. And let's make it a 4-inch tall. See if we can keep from getting that total height from being enough to spill that out. If it does, it's no problem. We'll go ahead. So now let's save that, exit that, and say, all right, so these optional outputs, there's our sections, and we'll say okay. All right, so it made it. Let's save and exit, and now let's view that. Didn't. Oh yeah, so I want set my colors. So edge of pavement will be gray. My curbs will be, let's make them cyan. And these others and outslopes will be green. We'll exit that. And then say okay. Let's process that. There we go. And now let's take a look at the surface. And this is what I wanted to show you about that, is that because we told it to use those colors, see how it shows us our curbs, and the side slopes, and the pavement. Okay, so the civil tools are quite a bit more extensive and they're quite handy to be able to do this. You know, we just designed the center line and the alignment and the vertical profile, and then we design the cross-sectional shape and it pushes it down that alignment for us, following the vertical as it goes. Okay, and there's a lot of options in there as well. Like you can put traffic islands, turn lanes, you know, bridge overpasses. There's all kinds of things that you can add to that. All right, but that's the basics. And if you only had survey, you can't use those particular tools, but you can do it by that way that we did the first go around. We just make the profile, we draw it, and we offset the edges, and then we tie the edges into the target surface. Okay?
Yep. Thanks.
Everybody feel good? All right. So
Yeah.
now, we wound up going a little bit over at the end of each day. So congratulations, those of you who are registered. You're going to get an extra hour of a PDH in case you need it. So we'll leave it at that. And so I'll get these certificates and the video links out probably, you know, by the first part of next week, maybe even over the weekend if I get some time. So we'll look for that. But you know, stay in touch. Have any questions? You got my email. You know how to get in touch. Just please feel free. Ask questions if you need. If you need a little extra, you know, reminder of where these things are. Practice in your book. You know, there's these different things that sort of reinforce all of these basic tools that we've been talking about. Also in the book, take the time, take the effort to go into these commands here in the command reference and learn about what some of these things do. Just sort of glance through them. Now, a couple of other things I want to point out as resources as you're working and learning this stuff. If you go to the help menu, And let's go to the Carlson manual. That's that top one there. You can see, you can find, you can do indexing and searching and go to the contents. And if you know like a command, you can look for it here. A lot of them are, they'll pop up context sensitive from inside a dialog box. But down here's a couple of things to look at. There is this tutorial section, and you've got CAD basics. Okay, so the CAD basics are going to give you a lot of those things, how to draw, what the interface does, how to issue commands, how to repeat commands, what happens with the right mouse button, how to cancel, how to navigate by panning and zooming. So all kinds of selection techniques, what happens in the properties bar, et cetera, et cetera. And so that gives you that. And there's another in the introduction section of the documentation. It talks up here about what it is and different concepts. So that's not a bad little thing to go through if you're needing to bone up on the CAD stuff. Those of you who do deed work, here's a thing on processing the deed, making a plat, field to finish. And this field to finish tutorial is quite extensive, so it will step you through using that, how to do intersections, subdivisions. Down here is some tools to using that surface design. We did that design pad template. That's right up here. We talked about that. We did this, we drew those edges and we elevated them, gave them some elevations. How to calculate volumes by different methods. Basic road design with volumes. So that's going to show you how to do that roadway design, with the profile and the template and pushing it down. There's your template editor. There's those curves. So that's just what we looked at. Now that requires the civil. Okay, so, but that's a nice little step-by-step approach as well. And it's pretty extensive as you go through it. So use those tutorials to help you. There's also on the help menu these at the Carlson website, but there's these online training movies, and these are really, really nice and helpful because it's got these different, and you can sort by different category. You can look at different playlists. These are just YouTube playlists. Let's see if we.
Where is that? Carlson video? I didn't see that.
That is, it's on the help menu. You may not have it.
I don't think I have it. I got Carlson. The help menu says survey manual, Carlson Academy, Carlson discussion groups, support options, Carlson website, and about Carlson survey.
Yeah, so you could find them from the website. If you go to the Carlson website, and then you can look over here on these quick links and you've got contact sales, there's downloads, there's knowledge base, and here's your movies. And that's going to put you into the same category. Okay, you can also get to that from the start page. See down here, you've got these.
Sure, yeah, I see it.
Reports and that kind of stuff. All right, so those are some resources to, please make sure that you use them because they're very helpful. And again, that YouTube library, just, search for what you're looking for because there's thousands of them on there. And they're usually just little short videos that, 15 minutes long that shows you how to do a particular thing you might be looking for. Okay, and they're really well done. So enjoy those, use those resources. Any questions? Everybody good? Based on your picture in our little screen there, John, you look like you've just been hit by a fire hydrant. So
it's about how I feel.
Yeah, turning green. So,
yeah, it's real good. This is excellent stuff. It's definitely something I'm gonna have to work up on many times.
Yeah. When you
You
do it,
you obviously have an incredibly deep understanding of the program, which is excellent. It's just sometimes when you're going to some of the drop downs, like I just couldn't follow you fast enough, and so like there came a point where I was actually following along 100%, and then I just had to like stop doing mine and just follow you and like
yeah.
watch you instead.
Unfortunately, especially under Zoom, it's hard to keep the whole class, at the same
Yep.
pace. In a face-to-face classroom, it's a lot easier, and COVID just knocked that out from under us, and we, haven't done a classroom training except for a couple of uh, custom classes that we set up in some different companies. Um, but they used to all be live in person, and it was a little bit easier. But the advantage to Zoom is that you have this video that you can always go back to and refer to. So those are going to be, you're going to get a link to a YouTube video that I maintain, a Carlson playlist, and you can see that once you get there. They're going to be private, so nobody else outside this class has access to them. But once you get the link, you can go to it, and then you can add that to your own personal playlists, and you always have access to it. Okay.
Excellent.
All right. Anybody else? Any questions? Any comments? Everybody ready for your Thursday?
Nah, just to say thanks, Ken, for everything that you did for us. This was a lot of information, but it's good stuff, and I think it's gonna take some time and some effort to go back through the exercises to get it ingrained. But
Yeah. And
I know I came away with a lot more information than I had coming in. So,
yeah,
especially when we were working the tin files and the brake lines,
yeah.
that was that was a good explanation. Thank you.
And what we did on our railroad project that you and I worked on, for instance, if you recall, we had those alignments and we did those profile designs, and we just pushed that alignment and
Right.
pushed the cross section down, and then we merged them into the ones where they intersected and backed them down to the loading dock. And,
Right.
there's just, uh,
Yeah,
uh,
that alignment that is so much simpler to build profile and sections using the civil and
yeah,
just being able to do that,
yeah, it
push that
surely is.
alignment. Yeah,
Yeah, it certainly is. One thing I forgot to show you here, I wanted to show you is, um, let's go to that cross section, because we processed that and we generated um, those cross sections. So if I look at my cross section uh, file, let's see what I wanted to. I want to do, oh, my section file editor. Sorry. So I'm going to look at my finished haul road, and I'm going to do a reference cross section of my existing ground, and then I can.
Hey, Ken, I'm sorry. I sent you a message there. I just want to let you know I got to duck out. I got a meeting here at 4. I got to jump in on, but I appreciate everything. I learned a lot. Thank you very much.
Absolutely. Like I say, stay in touch, and we'll see you soon.
Awesome. Thank you.
All right. Take care now. All right. So here, let's see. Let's go to maybe a 2-time vertical exaggeration. And I want to look at these. And so you can, investigate. Here's at that particular section or that station. And as you go, along the roadway, you can see, this is jumping section to section. So it's tracking all that kind of stuff. And you can use those section files you can actually even come in here and edit these section files to actually change the resulting surfaces and things that you've done. But the nice thing about if you generate those sections is, and you can even interpolate in between sections, all kinds of stuff. But the nice thing about that is, with that road design, is under the profile editor, let's load up that haul road FG, and it shows the existing ground. And while I'm here, now notice in roadway, as I move this along, you get a marker as to where you are. But if I look at here down below where it says show sections, I'm going to, let's see, use my template, no transitions, that's all good. So now here's my cross section over here, and I get not only those changing sections, but if you see up here in the top in these reports, in these numbers, you get the total cut and fill. So I'm 92 yards of cut and 25 yards of fill. So I could then take that to say, well, I got too much cut. Maybe I want to, raise this. I may see how if I do that and then let it process it, see now I'm a little bit more balanced. And I just did that graphically, but that has changed that entire network of that roadway. So as soon as I say save and exit and reprocess that, it's going to regenerate all that kind of stuff. But all of these numbers then are going to be closer to being balanced. So it's a nice little way to, help you if you're trying to real quick, you don't want to get, too much cut, too much fill. So
Yeah, that's a powerful tool. And then the other thing that you can put subgrade underneath that.
absolutely. And it will report all of the amounts that you need. If you got 8 inches of stone and 2 inches of base asphalt and then a binding course and all that, it will accumulate all that material and give you reports for all that stuff too. So
Yeah. Wow,
but
that's great.
let's take a
Yeah, that's great.
take one last little quick peek at these, and I look at those reports. I got to process first. All right. So process now my reports. And so here's now, you might remember a curb was right down here. You see how much concrete we need for the curbs on the left and the right. So if you had subgrade, you would see all those materials accumulated there as well, and it can put it in as a station by station kind of accumulation report. So it's really really a super tool, but it's way beyond the fundamentals class. But it's not
Sure.
hard, it's just it's just a little bit more complex, that's all. Okay.
Mhm. Yep. Thank you.
All right, folks, enjoy your weekend. I'm going to stop our recording.